Let the party begin. And today's marathon session is all about the concept revision, seeing all the theorems, seeing all the formulas, along with some really good questions for you guys to practice with me. And let's begin. Welcome, hello, bonjour, hello minions, hello everyone. Nice to see all of you out here after yesterday's lovely session of 11th standard revision. This is Shreyas here, your master teacher for physics at Vedantu, and I'm going live from Bangalore. Hello Priyanka, Hatim, Yalini, Uday, hello Karthika, hello, welcome. Oh, don't worry Karthika, you're not blocked. Don't worry, you're not blocked. Maybe the admin would have blocked yesterday for some other reason. Don't worry, you're not blocked. All right, so just ping us your actual account. We'll unblock you on the comment section. Hello Parma, hello Kiji, hello Sai, hello Modit, hello Nirupam, hello Hatim Ali, welcome, good evening. Yes, yesterday's session was amazing and we are going to make today's session even more amazing. And those of you who are very new to this channel, well, this is Shreyas here and I teach physics not just on YouTube but also on the regular platform of Vedantu. And I have been teaching in offline classes for a long time, and when I shifted to online, I realized that in fact I can reach to many more students than just limited to one center or just one small town or a city. And I'm really glad to be here in Vedantu because I can talk, I can give all my learnings, I can interact with all the students throughout the country and spread the joy of learning to all the students who want to crack the examination. And if you want to know more about me, you can definitely follow me on my Instagram handle Shreyas_Vedantu. Oh, by the way, there is something like IPL which is going on Instagram. Go check out the latest status update which I have put up on Instagram. Check it out and you will know more about that IPL kind of thing which is going on right now in Vedantu. All right, yes, super duper ready. Very good, Rahul. Yes, Karthika will cover the entire 12th session. Hello, Bhanusri. Hi, P. Nikhil. Welcome, Techholic. Hello, Science Priya. Hello, Creative Grish. Welcome. And please remember, if you are new, the only way you can make yourself known and make sure that you make new friends is when you interact with other students, introduce yourselves. Make sure to keep the chat box clean. At the same time, if you find some intruder, you know what to do. All right, make sure that you report the intruder and let's keep the virus out of our system. And before we begin, all the new timers out here, do not forget to hit the subscribe button down there. It's free. Yes, it's free. Go hit the subscribe button to get more such amazing updates. I'll tell you one reason why you should subscribe. Because, next week, the JEE Main exam is going to be conducted and we are going to discuss all the papers right over here. Yes, all the papers right over here. So do not forget to hit the subscribe button and to show your love and your support to this channel. Do not forget to hit the like button out there. Come on, show all your love, show all your support by hitting that like button out there. Hello, Uday Sagar. Hello, Guru Savria. Hello, welcome everyone. Hello, Garv. Hello, Shreyas student. Hello, Aishwarya. Welcome. So let's begin. So Creative Grish, in fact, I have not just created one video, I have created many videos. So please check the past videos. I have created many videos where you can see many sessions have been conducted on most expected questions for JEE. There was a 11th standard session, there is a 12th standard session, and before that also there have been sessions created. All right, so let's begin. And remember, tomorrow is going to be a mock test. So very important questions coming up tomorrow. And in case you have missed any of these marathon sessions or most expected questions which were conducted on Tuesday or Wednesday, do not forget to check it out. And also NCERT underline of communication systems and semiconductors which was conducted on Monday. All right, so we have another announcement for all of you. Yes, we have a kind of a carnival which is going to go on Enthuse, and that carnival starts tomorrow. We have mock test back to back. So Wazim sir, Shimon sir and me are going to discuss mock test. The test will be provided to you on the Telegram group. So make sure you solve it beforehand, before coming to the class. We are going to discuss it in detail. Then tough questions for JEE Mains on Sunday, and then on Monday, last minute tips and tricks. Very important session, last minute tips and tricks session by all of us. And Tuesday we are going to sit over here like a round table or like a virtual conference, and we are going to make sure that you stay motivated, and the last minute preparation which is required just one day before the examination, that's going to happen on Tuesday. Yes, so that's a carnival for all of you, the 4 days marathon for all of you from all of us. So do not forget to hit the subscribe button if you have not done it yet. So let's begin with our session. Now, remember, we are going to start with electrostatics. We are going to go to magnetism. We are going to go to current, electricity, capacitors, optics, EMI, you name it, AC circuits, modern physics, and light waves. Everything will be covered today, Pavitra. I'm very good. Yes. So, yeah, in fact, much more grander than what we did for KVPY Techolic. All right. So, for all of you. So, let's begin, guys. So, let's start with electrostatics first. Okay. Now, everybody knows the force between two charges is K Q1 Q2 by R square. The potential energy is K Q1 Q2 by R. Now, this is for electrostatics. Remember, if it was not charges, but if it was mass, the only change is instead of that K Q1 Q2, it will be F is equal to G M1 M2 divided by R square. And there is one small change over here. Instead of G M1 M2 divided by R, be careful, it is minus. So there is that minus sign which most often students forget. So do not forget that minus sign in case of gravitation. Keep that in mind. Cool. Great. So having said that, okay, I hope you are making notes simultaneously. And one more advantage of joining our Telegram group, whatever you see on the slides, except for whatever I write, will be handed over to you as a free PDF on our Telegram group. So do not forget to hit the Telegram group link, all right, which is there in the description box below. Okay, whatever I write, you have to note it down at least. Okay, now Gauss's law, very important to find electric field of unknown geometries. Now Gauss's law says net electric field dot the area vector at every point is the enclosed charge by epsilon naught. So very important. So say for example, you have a surface. First, for applying Gauss law, very important, you need to choose a closed surface. Always choose a closed surface. Something like a cube, a cylinder, a sphere, anything. Choose a closed surface. Some charges might be outside. All right, some charges might be outside and some charges will be inside. Remember, in the RHS, this Q only stands for the charges which are inside, not the ones which are outside. Keep this in mind. So it is enclosed charge by epsilon naught, that's number one. And this quantity over here, this quantity that you see over here, this is the net flux. Yes, this is the net flux over that closed surface. So net flux over the closed surface is Q by epsilon naught. Always keep this in mind that if enclosed charge is positive, then net flux is positive. That means it is going outwards. Sign convention, keep this in mind. If it is positive, then it is going outwards. If it is negative, then it is coming inwards. If it is zero, then that means the number of lines which are coming in and the number of lines which are going out are equal in number, or there is no flux only. Both possibilities are there. If it is zero, then either there is no flux or number of lines coming in and the number of lines going out, both are zero. Yes, I hope this is clear. Okay, yes, Techolic, I have been told about that. In fact, I have been told that I also look like Adar Punawala. I don't know why. Okay, chalo, let's get going. I hope you have made notes about this. Yes, Mudit, don't worry, we are also going to do some problems. So this is a problem come, formula come, concept come, theorem session. So all kinds of things are going to be there. All right, cool. So let's get going with the next one. Now, having said about Gauss's law, where do you use Gauss law? To find electric field of common geometries. Example, like cylinders or spheres or sheets and stuff like that. Remember, whenever you choose a Gaussian surface, always choose a surface which is easy to integrate. Preferably, show the electric field lines or visualize the electric field lines and choose the surface such that the field lines are either perpendicular, alright, the field lines are perpendicular to the surface or they are parallel to the surface, because then doing this dot product will be easier. So if it is perpendicular, you know what to do, and if it is parallel also you know what to do. So either it is 0 or it is 1, so that makes the integration simple. Keep this in mind. Now the most important properties of a conductor, very important properties of a conductor. Hello Stra, hello Nevia, hello, welcome. So Kartika, inward and outward means so if the field lines are coming inside the surface, that is inwards. So if it is a negative charge, the field lines will come inside. If it is positive, the field lines will go outwards. That's how it is. Cool? I hope this is clear. Oh, Hatim Ali also has explained that. So very important properties. All the charges on the conductor always lie on the surface. Now imagine this, if you had, alright, if you had a solid sphere, okay, if this is a solid sphere, if you charge it, remember all the charges are going to come on the periphery and it will behave like a shell. It will behave like a shell. Keep this in mind, because in a shell, where are the charges? Only on the periphery. So a solid sphere which is charged will behave like a shell, provided that solid sphere is a conductor. But if it is an insulator, then please understand this. In an insulator, the charges can remain inside the conductor, inside the insulator also, wherever you place it. They are not free to move. Only in case of conductors, they repel each other and they are always on the surface. Number one property. Number two, charges accumulate at the sharp edges. Alright, very important. Charges accumulate at the sharp edges or the bends. So, if you have a diagram which is like this, then understand this is sharp. So you will see more charges over here, alright, more charges over here, and there will be less charges over here. Very important. Now, talking about conductors, next properties, the entire solid surface of a conductor is equipotential. Very important property. If you take the entire surface of the conductor, alright, no matter where you go, the potentials are equal. So, imagine guys, if you have a conductor something like this. This point, all the points are at the same potential. Keep this in mind. So there is no potential difference between any two points, even when they are connected. When they are connected, both their potentials become equal, and the potential difference between any points on the conductors is 0. All are equipotential. They behave like one single conductor. And last thing, when a conductor is connected to earth, the entire potential becomes 0. So it's not just this point. All the points on the conductor will get 0 potential. Keep this in mind. Alright, keep this in mind. Okay. So very important properties. Keep this in mind. Let's get going to the next one. And before going to the next one, let me also tell you one more important thing about electric field and potential. If you have any randomly shaped conductor, remember one thing, that the field inside is always 0 and the field outside is always perpendicular to the surface. What is the field going to be? The field is always going to be perpendicular to the surface, but it may bend later on, that's okay. But the field is always going to be perpendicular to the surface. This is the electric field. Keep this in mind. It's always going to be perpendicular. And one more thing, the potential line is always going to be perpendicular to the electric field. The equipotential lines, they are always going to be perpendicular to the electric field lines. Keep this in mind. These are the equipotential lines. Yes. And they keep on growing, larger and larger. All right, cool. Very good. Let's get going to the next one. Okay, I hope you have made notes of all of this. Okay, so going ahead with the next one. There we go. Very important diagram which relates everything about field, potential energy, potential. All these things, field, force, potential energy, potential, all these things can be related to each other. Look at this. Force is kq by r square, which is expressed in newtons. Now, force per unit charge is nothing but field. And field is kq by r square, which is Newton per Coulomb. So from force, if you want to find field, remove one charge. Per unit charge, what is the force? That is called as field, the Newtons per Coulomb. If you know the field, to find the force multiplied by charge, you get the field. You get the force. So the field into the charge gives me the force acting on the charge. Very, very interesting. Similarly, if you have potential energy, all right, if you have potential energy, which is KQQ divided by R, which is in joules, the potential energy per unit charge gives you nothing but the potential, which is nothing but KQ by R. So one of the Q has gone because that is joules per Coulomb. If you know the potential at that point, if you multiply it with Q, you get the potential energy which is added because of that extra charge. Very important diagram. Yes. So Chirag, this is live. All right. Yes, Nikhil, we are also going to have live questions today. Yes, we are going to have that. Very important. Cool. Yes. Cool. Welcome. No, it is not potential difference. This is potential. V1 minus V2 is potential difference. Keep this in mind. So 2 points potentials. If you subtract, you get potential difference. Very important relationship to go from one side to the other side. Force divided by charge is field. Field into charge is force. Potential energy upon charge is potential. Potential into charge is potential energy. All right, cool. Let's get going to the next one. Very important. See, we went sideways. Now let's go top to bottom. If you know force, you can go to energy. How? Like this. If you integrate force with position, all right, from one point to the other, the negative of that gives you du integral. So du is minus f dr. It's very easy to remember. I'll tell you how. Go the reverse way. Force is minus du by dr. Everybody knows this. Everybody has studied this in potential energy. Force is minus du by dr. Take dr on the other side. If you take dr on the other side, won't you get this? So that's how you go from force to potential energy or from potential energy to force. That's how it is. Keep this in mind. Okay, cool. Very good minions. Very good. Similarly, you have field to potential or potential to field. See, because force by charge is field and potential energy by charge is potential, the same relationships are going to hold true. Look at that. So when you have potential, minus dv by dr gives you field. Just like over here, minus du by dr is going to give you force. Here, rate of change of potential with respect to distance with the negative sign gives you field. And when you integrate this, take dr over there and integrate this, you get integral dv is minus e dot dr. Keep this sign. Alright, Avinash, why that minus sign? That has been explained in potential energy chapter. The whole idea is the work done by the conservative force is negative of du. It comes from there. So there is a small derivation for that. The work done by a conservative force is negative of the change in the potential energy. It starts from there. Alright, cool. Great. Let's get going. Yes. Okay, cool. Done. Okay, chalo. Let's get going to the next one. Now, all the formulas which are important, I'm going to give it to you right over here. Very important formulas and graphs. These can come as direct questions in your JEE Mains examination or even in your BITS examination or even in your NEET examination. Doesn't matter. First thing that we are going to study, uniformly charged sphere. If a sphere is uniformly charged, then what is the formula? The field will change with distance. But there are two situations or cases. Once when you are outside and once when you are inside. When you are outside the charged sphere, then the charged sphere behaves like a point charge and the formula is very simple, kq by r square. But when you are inside the charged sphere, then it is kq r by r cube. Keep this in mind, kq r by r cube. And the graph will look like this. In fact, you can remember it graphically. Look at that. The graph is a straight line first. So you can see that small r over here. So till you reach the surface, it is directly proportional. But the moment you are outside the surface, that small r, which is a variable, comes below and then it starts decreasing. You can see that because that r has come below. Yes, this is for solid sphere which is uniformly charged. You can see that uniformly charged solid sphere. Similarly, the value of potential when you are outside, all right, it is going to behave like a point charge. So simple formula, kq by r, as simple as that. But when you are inside, all right, so this was when you are outside. When you are inside, the potential is constant. Remember, I just told you some time back. So the potential is constant. Just 1 second. This, if it was uniformly charged, it's going to have a slightly different formula. 1 second. I don't think it has come out completely. So the formula comes out to be like this: 3r square minus r square, the whole thing divided by 2r cube. So this is the complete formula. The other things were not printed. So that's why the graph goes like this. You can see when you are inside, there is a quadratic term over here. Do you see that? There is a quadratic term over here, r square. So that's why the graph is also a parabola over here. It's a parabola over here. But when you go outside, you can see that r, that variable r comes below, and that's why the graph is going to go down like this. Keep this in mind. Yes. I hope this is clear. So this one over here is field versus distance. This one over here is potential. This is potential versus the distance. Keep this in mind. All right. Keep this in mind. So Eduner, this is an English channel. The normal Vedantu JEE channel is a Hindi or Hindi English channel. Understand? So that's the difference. Okay, cool. Let's get going to the next one. I hope you have noted it down. So 3r square minus r square divided by 2r cube. That's the formula for that. Okay, cool. Let's get going to the next one. Ring formula. My wishes are with everyone. Ring formula. Field formula is like this: kqx divided by r square plus x square whole raised to 3 by 2. If you are on a ring, on the axis of the ring, if you change the distance, this is the formula: r square plus x square whole raised to 3 by 2. But potential, there is no 3 by 2 and there is no x on the top. Keep this in mind. There is no x on the top. So that's one big difference. And there is a very simple way to remember this. When x is 0, on the ring or at the center of the ring, the field will be 0, because everywhere the forces will act and it will cancel out. That's why when x is 0, field is 0. But when x is 0, potential is not 0, because potential is a scalar quantity. So in fact, all the potentials will add up at the center, and that's why when you substitute x as 0, potential does not become 0. So you can see graphically the field starts from 0, increases and then decreases. Very important graph to remember. Karthika, U is potential energy, V is potential. Similarly, the graph for just potential will start from some value, and as you go away, it just keeps decreasing. That's all. That's all. Cool. I hope this is clear. You have noted it down, all the minions out there. Okay, cool. Very good. All right, let's get going to the next one. Next formula coming up on your screen, and here it is. Field due to a line charge. When you have a line charge, all right, where lambda is the charge per unit length, how many coulombs is there per meter, that is lambda. Then if you are at some distance from that line charge, all right, and the ends of that wire subtend angles alpha and beta, all right, all these charges are going to apply fields in various directions. So the resultant field will have two components. One is the x component, one is the y component. The x component is given by k lambda sine alpha plus sine beta divided by r. R is the distance from where you are standing from that wire. Next up, the y component of the field, instead of sine it is cos. K lambda cos alpha, be careful, minus cos beta divided by r. Now how do you remember the signs? Because a lot of people get confused with this. See guys, think about it. Imagine a situation where alpha and beta are equal. Just imagine. If alpha and beta are equal, all these charges will apply fields like this. Alright. All their y components will get cancelled. Only the x component will remain. Correct? Only x will remain. So if alpha is beta, then the y component should be 0. So that's why there is a minus sign. So when you put alpha and beta both as equal, you will see both of these terms cancel out and this component comes out to be 0. That's how you can remember plus or minus. That's how it is. Cool. And remember one thing, this is sine alpha plus sine beta. And how do you remember this is sine and sine? Very easy trick to remember this. See guys, if it is an infinitely long wire, then the value of alpha and the value of beta both will be 90 degrees. Both alpha and beta both will be 90 degrees. That's it. So think about it. Think about it. So when you put sine 90 here and sine 90 here, it will become 1 plus 1. So you will get some value of the field due to an infinitely long wire. If it was not sine but cos, then cos 90 and cos 90 will make it 0, which should not be correct. So that's how you can remember that it will be sine and not cos. Yes, Ananda, that's what I just did that. Yes, very good. So keep this in mind. If it is an infinitely long wire, then both alpha and beta will be 90 degrees. Keep this in mind. Cool. Let's do this. Next up, coming up on your screen, field due to a charge sheet. Field due to a charge sheet. What is it going to be? So the field due to a charge sheet is going to be sigma by 2 epsilon naught. Please understand the field lines are going to go both ways. Yes, the field lines are going to go both ways. The field line, the field value is sigma by 2 epsilon naught. What is this? This is coulombs per meter square. The surface charge density, that is sigma. Keep this in mind. All right, all right. Yes, cool. So lambda, Kartika, that is nothing but linear charge density, which is coulombs per meter. How many coulombs is there per meter? That is nothing but lambda. Okay, charge density but linear wise. Okay, now next let's talk about dipole. Thank you. Hello Lakshmi, hello Khushi, hello. Welcome, welcome, welcome. All the new timers out here. Okay, cool. Dipole. What is a dipole? Dipole is a collection of a positive as well as a negative charge of equal amounts. The distance between them is L. Now a lot of books use the formula 2QL, but I will not do that. I will assume only the distance between them as L to keep things simple. It is much easier to do it that way. This P, what is this P? This P is called as the dipole moment. This is nothing but the dipole moment. So the dipole moment is nothing but the charge into the length of the dipole. Keep this in mind. Charge, any one charge into the length of the dipole. That's dipole moment. Now there will be field lines because of this dipole like this. Correct? There will be field lines because of this dipole. So what is the field due to the dipole on this line and on this line? There are two formulas, very important formulas. On this line, which is called as the axial line or the axial position on that dipole, the formula is 2 kp by x cube. What is x? X is the distance from the dipole. So you'll be like, is it from the positive or is it from the negative charge? Now keep this in mind. This is valid when x is much larger than the length of the dipole. So it doesn't matter whether it is positive or it is measured from positive or negative. The dipole is very small and you are really far away on that axis. So that's why it doesn't matter. So on the axial length, it is 2 kp divided by x cube. Yes, x is that distance from the dipole to where you want to measure the field. Next up, on the y-axis, what is that called? Equatorial axis. On that equatorial axis, how far you are from the dipole? How far you are from the dipole? That is nothing but y. And the field on that point, on the equatorial region, is kp by y cube. I hope this is clear now. Okay, this is very important. So remember, whenever you have a dipole, something like this, this is your axial length and this is your equatorial length. Remember one thing, on the equator, the field will be like this way, because the field lines will start from the positive and it will end at the negative charge. So that's how it's going to look like, the field lines. And you can see on the axial length, on this axis, you can see the field lines are more concentrated over here. That is why you have this number 2. On the equator, you do not have that number 2 because on that equator, the field lines are less in number. but on the axial position, you can see lot of field lines are going to be there. That's why 2 number is going to come. That's how you can remember this. In fact, that's an easy way to do that. So I just mentioned x is the distance from the point till the center of the dipole. Okay, cool. Okay. Good to see you, Sakti. All right. Okay. Now, if at all there is a problem, all right, if at all there is a problem where it is neither on x, neither on y, there are 2 options, guys, with you. Let's say, for example, there is a dipole like this and there is some angle, and let's say this is r. Okay, there is some angle and at some distance you want to find what is the net field. There is a very simple way of doing this. The formula comes after splitting this dipole into 2 parts, one like this, one component like this, and one component like this. So this is one component and this is second component. So you can see for this dipole, this is the axial length, and for this dipole, this is nothing but the equatorial length. So with all the mathematics, you will get the final form as something like this. The electric field, all right, will come out to be Kp divided by r cube into root of 3 cos square theta plus 1. So that's what the formula is going to look like. Be careful. Okay, keep this in mind. Yes, that's how it comes. All right, Uday Sagar, I hope this is clear. Yes, that's how it comes. So keep this in mind, very important formula. Now, if somebody asks you, what is the potential on this equatorial line? These kind of questions have come. On this equatorial line, what is the value of potential? The answer to that is always 0. Keep this in mind. Why? Because all these points are equidistant, guys. So whatever positive value you get, exactly the same amount of negative value you will get. So the total potential on the equatorial line will always be 0. Keep this in mind. Cool. Okay. Now, when you place that dipole in somebody else's field, please understand the previous part was the field because of a dipole. Alright, these field lines were created because of these charges. Now, if you place these charges in somebody else's field, this E is not because of this dipole, somebody else's, then that dipole will always experience 0 force if this field is uniform. Very important, because the force on the positive charge and the force on the negative charge will always cancel out each other. The force on positive and the negative will cancel. That's why you will see the net force is 0 on it. But the torque is not 0. In fact, it is P cross E. Very important formula, P cross E. That means the torque will try to rotate it and bring that dipole aligned in the direction of the field. So when it is aligned, then the torque acting will be 0, because then the dipole moment and the field will be in the same direction. If you try to rotate it anyway, it will try to always bring it back. Keep this in mind. Also, the potential energy is minus P dot E. This is assuming 90 degrees as 0 potential energy reference. So if you take 90 degrees as 0 potential energy, then the potential energy at any point is minus P dot E. It's a dot product. Keep this in mind. Very important formulas for solving problems. Many questions come. Sometimes there have been questions like this over here. So there was a question given where the charges are there is a rod and the charges are attached at the end, and the rod is displaced by a small angle theta, and the question is, what is the time period of oscillation? Guys, it's such a simple question if you realize that the torque acting is PE sine theta. Alright, torque acting is PE sine theta, and for small angles, sine theta is approximately theta. So small angles, sine theta is approximately theta. Now the moment you show torque is proportional to theta, this becomes your constant of proportionality. Therefore, the time period just becomes 2 pi under root moment of inertia of that system divided by that constant, which is P. So these kind of questions have come in JEE examination. Lakshmi, the session is going to last for at least 2 hours, just like yesterday, because we are covering all the 12th standard syllabus. So remember, all the 2021 aspirants, this is a very important session for all of you, because we are going to do the entire 12th standard portion. All right. Next up, remember all the field line diagrams for all these different kinds of systems. Very, very important. There could be many more. So you should know how this works. Field starts from positive, ends at negative. More the charge, more the field lines. How the field lines get pulled towards the negative charge. How the field lines do not cut through a conductor. They end or start from a conductor. They cannot pass through a conductor. Very, very important. Alright. Field lines are always perpendicular to the conductor. Similarly, for two equal charges or like charges, how the field lines try to move away from each other. Remember that for gravitation, the field lines are always attractive. Remember, two masses can never repel each other. Alright, charges can, but masses cannot. So for gravity, the field lines are always attractive in nature. And another thing, the field lines due to charge plates, how they are almost parallel except for the ends where they slightly bulge out, which is often neglected when the plates are very, very large. Alright, cool. Let's get going to the next one. And here it comes. Whenever you have problems of shells or plates, a very important trick which I can give you right away. For example, there is a shell problem and it is given to you on this shell. There are two shells. On this shell, let's say the charge is 2q, and let's say the charge on this shell is example, let's say 5q. Example. What will be the charges on each shell? This is the logic to be used. Remember, simple trick. Always the innermost surface will have zero charge unless there is another charge inside. So if this is 0, by conservation, this part should have 2q charge. The outer surface of the inner shell. Then if this is 2q, this should have minus 2q. Always the opposite faces have equal charges but opposite sign. Now if this has minus 2q, to conserve the charge and maintain it at plus 5q, this will be 7q on the outermost side. That's how it works. Keep this in mind. Yes. Similarly guys, imagine another situation where there was another charge over here. Let's say 2q like this. Let's say this was 3q. Let's say this was 4q. Example. Then what will happen? Be careful. The innermost surface will not have zero charge. Because there is 2q, here you will have minus 2q. Be careful. Opposite. Always opposite sign, equal magnitude. And if this is minus 2q, then this one, to conserve the charge and make it totally plus 3, it will have plus 5q charge. Minus 2 plus 5 is plus 3 to conserve the charge. If this is plus 5, this will be minus 5q. And if this is minus 5, to keep it 4q, come on guys, think about it. This should be nothing but 9q. That's how the charges are. Keep this in mind. Very, very important. Yes. Okay. If one plate is grounded or earth, then what do? Let's say one plate is grounded or earth. Then if it is this one, then make the potential of this as 0, and this charge will no longer be 9q, it will be some q. I do not know how much q. And now try to make the potential 0. So the potential at this point is because of this and this. And from that you will get the value of q. Okay? I hope this is clear. Well, Matthew, yes, don't worry. Even Wazim sir will take. Don't worry. Okay. Now concentrate on this class for now. Okay. I hope this is clear. Next up, the trick for plates. Very important trick for plates. If let's say there is 2q, 3q, and let's say 5, or I don't know, maybe q charge over here, just giving you an example. Then what are the charges on the plates? Very, very important. Add up all the charges. 2 plus 3 plus 1. How much is it? 6, right? 2 plus 3, 5, 5 plus 1, 6. 6q divided into two parts. 6q ko divide. Yes. So it will become 3q here and 3q here. Now do the rest. Conserve the charge. If there is 3q here on this side, it should be minus q to conserve it to 2q charge. If this is minus q, opposite will have plus q. If this is plus q, to conserve the charge, this should be plus 2q. Alright, and if this is plus 2q, this should be minus 2q because opposite faces. That's how it works. And remember this trick always works and helps you save a lot of time. Cool. Very good. Very interesting tricks for all of you so that you can crack the examination. Let's do some problems now. Now, before going to problems of electrostatics and Gauss law, let me give you a very important update for all those 12th and the dropper students who wanted only a test series, we have created a test series for all of you which has 10 tests before the February attempt and 10 tests after the February attempt for the March one, the second attempt. These are 20 full-length test series for all of you, which has been designed by all of us. It contains entire syllabus, and I'll tell you what is the best part. It's in English. There is an English batch available for all of you, and I'll tell you the second best part. We are going to discuss all the questions. It's not like we are just going to discuss 5 questions out of those 30 questions. No. If there are 20-30 questions, we are going to discuss all those questions, not like other institutes, because we believe that we need to discuss each and everything so that you guys understand. And if you want these discussion sessions, go ahead, check it out in the description box below. There is a link for joining the test series, and this test series has already just started. So go ahead, register yourself now, because in the last few days, it's very important that you write many mock tests and also attend the discussions so that you realize what your mistakes are. Usual price is 2,500, but on discount, alright, when you use the coupon code SHCC, you get it for only 1,749. Till yesterday, it was 1,999. There is an additional, yes guys, there is an additional discount. This is the lowest price you can get. I think you should go ahead and register yourself right now, because it is hardly some 90 rupees or something per test. That is really cheap price that you're getting this test for. Go ahead, check out the link in the description box. Cool. Yes. Let's get going to the next one. Geeta, one thing you can do, you can also pause the video, because there are many things which we are going to cover today. Okay, cool. Yes. Okay, so Rihan, no, this is not going to decrease again. This is going to be the least price. Again, after 1 or 2 days, or I'm not sure, it might even increase tomorrow. It is going to go back to again 1,999 rupees. Yes, cool. Let's get going to the next one. Oh, it's somebody's birthday. Ankit's birthday was there. I'm not sure where he is, but anyways, happy birthday, Ankit. In case you are here and listening, all the very best, and may God bless you. All right, let's see how many of you get this. Okay, a charge Q is situated at the center of a cube. The electric flux through one of the faces. Many of you have written D. Excellent, guys. The correct answer is actually D. And the reason for that is because these are 20-30 second questions. Because when you have a cube like this, and if you have a charge located at the center, each face will have the same flux cutting through it. Each face will have the same flux cutting through it, and you will see that since there are 6 faces, so I can say that from any one face, the total flux is nothing but Q by epsilon naught, which is nothing but the total flux divided by 6. So that is the answer, Q by 6 epsilon naught. Very good. Yes, let's get going to the next one. Let's see how many of you can get this. Here it comes, 2005 actual question. The magnitude of the electric field on the surface of a sphere of radius r having uniform surface charge density sigma is how much? What is the value of the surface charge density? Sigma by epsilon, sigma by 2 epsilon, sigma by epsilon r, sigma by 2 epsilon r. What is the magnitude of the electric field? Come on, think. Glad to know that, Athar Sangle. Thank you so much. Okay, B or C? Come on, decide. B, C, A. Lot of you are saying B. Well, I'll tell you what. Breaking news. The answer is A. A lot of people make this mistake. Now remember this. Now pay attention. That is why this is a previous year question. See guys, when you have a sheet, okay, like this, then understand the field goes both ways. And that value of field is sigma by 2 epsilon naught. Okay, but when you have a conductor like this, maybe this is a conducting surface. Okay, so this is a conductor. Understand the field is only going to come one way. There is no field inside. E in is 0. Here think of it, sigma by epsilon naught is this way, sigma by epsilon naught, or rather think of it this way, sigma by epsilon naught is divided into two parts, one this side, one this side. So each part is sigma by 2 epsilon naught. But when you have a conductor, the fields are only coming one side, so that's why the field is just sigma by epsilon naught. So here the magnitude of field on the surface of a sphere, this sphere is nothing but like a conductor, is sigma by epsilon. Yes, keep this in mind, keep this in mind, be careful. This is a common mistake which people do, and that's what, you know, paper setters are going to look for. They are going to lay traps for all of you. Be careful. Okay, now next question coming up. There are two spheres which are conductors A and B of radii 1 and 2 millimeters, separated by a large distance of 5 centimeters, and they are uniformly charged. If the spheres are connected by a wire and in equilibrium, then what is the ratio of the magnitude of the field at the surface of sphere A and sphere B? Come on, let's see how many of you do this. Come on, not more than 40 seconds to 60 seconds, not more than that. Yes, come on. Weekend Kid says A, I'm not sure. Mid Oasis say C. All right. Let's see what is the correct answer. Come on, guys. Okay, C, A, B. Okay. Well, let me tell you what. See, when you connect two spheres, okay, and the radii are 1 millimeter and this is 2 millimeter, okay, let's say this is R2, let's say this is R1. What is going to happen? Their potentials are going to become equal, all right? So their potentials, V1 is going to be equal to V2. And what is V1? K Q1, all right, divided by R1 is going to be K Q2 divided by R2. All right, so I'm going to get Q1 by Q2 is nothing but R2, is going to be R1 by R2. Now, the question is not about potential or charges, it's about field. The question is, what is the magnitude of the electric field, the ratio? So, what is E1 by E2 going to be? Well, E1 is K Q1 by R1 square and E2 is K Q2 by R2 square. K goes, so I'll get Q1 by Q2 into R2 by R1 whole square. Now Q1 by Q2 is R1 by R2. So when I put R1 by R2 into R2 by R1 whole square, what am I going to get? Each R1 and R2 are going to cancel out. I'm going to get R2 by R1. So R2 is 2 and R1 is 1. So the answer is 2:1, and that is option C. Very good. Very good. I hope this is clear. So that's how you need to solve this problem, guys. Very interesting question. Yes, the correct answer is C. Some of you are saying A, and also some of you are also saying B before this. Be careful. That's not the correct answer. Okay, very good. Let's get going to the next one. C, option 2:1. For a given surface, the Gauss law is stated as sigma or summation or cyclic integral E dot ds is 0. From this, we can conclude that which of the following option is true? Only one option is true. Let's see how many of you get this. Very good, Arya. Very good, Science Priya. Very good, Yalini. Very good, Princey. Very good. Very good, Mudit. Yes, Buna. Very good. Very good, Hatemali. Very good, VK Vinit. Excelente. Very good, PK Nikhil. Let's see whether you get this. Oh, by the way, if you're new to this channel, this is an English channel where we prepare you for the upcoming competitive exams. And this channel is in English because not many channels teach in English in our country, and we decided that we should get together and create something for you. And this channel is absolutely free of cost for all of you, and it will always remain so. So go hit the subscribe button, and if you want to get more updates, more videos like this, and do not forget to show your support by hitting that like button down there. Go smash it if you have not done it then. All right, so many of you are saying C, and very few people said B as well. Okay, don't worry guys, let's do this. The correct answer is going to be C actually. Yes, most of the minions have got the correct answer. So if this is 0, what it means is that, all right, the flux, all right, the flux is 0. The net flux, the total flux is 0. Now if total flux is 0, what it means is that if you have a Gaussian surface, alright, this is just imagine a surface, alright, there could be multiple things that are possible. Is E 0 on the surface? Is E necessarily perpendicular to the surface? Alright, and is the total flux 0? Well, the total flux is 0 obviously, but what about other options? Let's just look at it. The flux is only going out of the surface. No, see guys, it's possible that the field lines entered in and went out. So this is the electric field line. The number of field lines that went in also came out. So if this happens, think what will happen? The in flux is equal to the out flux, net flux will be 0. Does it mean E is 0 on the surface? Do you see that? E is not 0. Is E perpendicular to the surface? No. And is the flux only going out? No. In fact, the flux going out and in both are same. Yes, I hope Sakti now it's clear. E is not necessarily perpendicular. You can see that. You can see it can make some angle as long as the number of lines piercing in and piercing out are equal. That's all. Cool. Yes, very good. Let's do this. Let's do this. Alrighty. Let's get going. And I hope most of you minions have got your friends also today. I'm really glad to see all of you out here. Welcome. All those people who are joining in new. You can, this is Shreyas here, and we are doing the physics revision of 12th standard for all the students who want to crack the JEE exam. And today's session is going to be a booster session. It's going to boost your marks by at least 10 to 15 marks. That is a big difference. It is going to change your rank by a lot of amount depending on where you get that rank. So guys, attend this session properly because this is a rank booster session and guaranteed rank improvement will happen just by attending the complete session properly. Very important to stay till the end. And also remember, watch this session 100 times. How many ever times you require for the first, second, third, fourth attempt of JEE Mains, because we are going to do everything of 12th standard. Next, types of capacitors. Yes, let's do this. Type of capacitors. And here it goes. First, parallel plate capacitor. What is the value? Keep this in mind. Epsilon naught A K by D. Very important. Epsilon naught A K by D. And the field inside that capacitor, is given by Q by A epsilon naught. Keep this in mind. Field inside the capacitor is given by Q by A epsilon naught. Keep this in mind. Okay. Next, what is K? K is not that 9 into 10 to the power 9. K is the dielectric constant. What is D? Distance between the plates. What is A? Area of the plates. Very important. Next up, cylindrical capacitor. 2 pi L epsilon naught. VK, come on, focus on the session. Bhai, मेरे को हिंदी आती है, but we are going to talk in English. This is an English channel. Alright. 2 pi L epsilon naught ln B by A. 2 pi epsilon naught ln log B by A. And the field inside a cylindrical capacitor, it's not constant. Be careful. It is inversely proportional to R. And what is this lambda? Again, charge per unit length. So this is nothing but charge per unit length. So length and charge, that's how it comes. All right. Okay. I hope this is clear. All right. Yes, very good. Next up, coming up on your screen, the spherical capacitor. The capacitance is 4 pi epsilon naught 1 by A minus 1 by B. A and B are the radii of that spherical capacitor, 4 pi epsilon naught 1 by A minus 1 by B, whereas the field is slightly different. It is not 1 by R, it is 1 by R square. So keep this in mind. 1 by 4 pi epsilon naught Q by R square. These kind of questions have come in the JEE examination. Alright, VK Vinith, thermodynamics was done yesterday in 11th standard syllabus. Okay, next up, energy stored in a capacitor. What is the energy stored in a capacitor? Half CV square or half Q square by C. Both of them are very important. Yes, half CV square or half Q square by C is the energy stored in a capacitor. Next up, very important type of question. Guys, they will give you some capacitor is there, some battery is there, and some circuit connection happened, all right, some switch was closed, opened, how much was the heat lost in the circuit, etc., etc. Remember this governing equation, you will never get this wrong. The work done by the battery, what is it? The work done by the battery, all right, goes in two things. Number one, changing the potential energy of the capacitor plus the remaining is heat loss. And what is that work done by the battery? The work done by the battery is how much charge flow happens multiplied by the EMF of that battery. Keep this in mind. So very important equation for all of you for calculating heat losses in capacitor circuits. Keep this in mind. All right. Very good. Yes, thank you Devashish. Glad you liked it, and today's session is also going to be even more amazing. All the 12 standard formulas out here. Very good. Yes, keep this in mind. Yes, half QV is also there, just one. But if you remember these two formulas, most of the times your job is done. Okay, now next up, energy density. The energy stored per unit volume, all right, in a field is half epsilon naught E square. Very important formula, half epsilon naught E square. Epsilon naught is permittivity of free space, is electric field. Energy density, so this unit, keep this in mind, is joules per meter cube. Remember, in magnetism, all right, in magnetism the formula is slightly different. It is half, instead of electric field you have magnetic field, and instead of permittivity you have permeability, but it comes downstairs. So that's how it looks like in magnetism. Okay, thank you Mr. Ois, thank you Anand, Akash, thank you so much. Saran, I'm from Bangalore right now, but originally I'm from Pune. All right, next, very important tricks for solving capacitor and resistor problems. Keep this in mind. When a capacitor is completely charged, it's charged, it does not allow the flow of current. Because it does not allow the flow of current, it behaves like an open switch. Very important, it behaves like an open switch, no flow of current happens. So if there is a capacitor, forget that there is a capacitor, think there is a blockage over there. Okay, so in that branch, no current will flow. But when you just connect a capacitor to a battery, when the current just begins to flow, then the current flows as if the capacitor is not there and as if it is a wire. So when questions are asked like this, capacitor is just connected, switch is just closed, then forget the capacitor, replace it with a wire. Very important. Very important. Yes, keep this in mind. Come on. Yes, Hatim Ali, correcto. Come on, everyone, do this. Yes, Tornado, focus on the session. Come on. Nishma, focus. All right, I know many of you are very anxious and you guys are, consoling each other that, oh, when is your exam, when is her exam, when is his exam. I know guys, don't worry, we have come up with a carnival session for all of you. So minions, listen in. On Saturday, Sunday, Monday, Tuesday, 4-day marathon session. Saturday, mock test. Sunday, tough problems. Monday, special tricks and tips before the exam. And last day, motivational session by all of us, because you are not going to study on the last day. You need that motivation. You need to cheer up. You need to relax yourself on the last day. We are going to do that. Hello Hitesh Kumar, welcome to this channel. Yes, Kia Carnival to nahi hai Vatsalya. Well, it's going to be a different kind of carnival. All right. And those of you who want to get to know more about me, do not forget you can follow me on Instagram to get all the regular updates, or you have any doubt in your mind, please ask me on Shreyas_Vedantu. The link for the Instagram is also pasted in the description box below. Okay, next, charging capacitor and discharging capacitor. Very important. Ankit, I wished you happy birthday. I think you are not there, but wish you a very happy birthday and God bless you, Ankit. May you do really well. God bless you. Okay, charging formula CE, all right, 1 minus e to the power minus t by RC. The graph for charging looks like this. It looks like this. And when the time is equal to RC, very important, when the time is RC, which is the time constant, then it is 63% charged. It is 63% charged. Yes, NVIDIA, I'm going to do optics also. Okay, very good. Next up. All right. Remember, you can also find the current. How did you get this current value? Well, this current has come because of differentiation. So dq by dt, when you take the derivative, this is what you're going to get, the current in that. Very, very important. And this is 63% charged. Keep this in mind. After one time constant. Now, when you are talking about discharging, if the charge on the capacitor discharges across the resistor, the charge slowly dies out. But during discharging, after one time constant, it gets 63% discharged. Keep this in mind. So this was 63% charged, right? Here it gets 63% discharged. Keep this in mind. Discharged. So only 37% is remaining after one time constant. Time constant is RC, and the formula for charge as a function of time is very similar. Just this 1 minus is not there. It's just the charge, because CE is nothing but charge, right? Q is CV. So charge into e to the power minus t by RC. Again, if you differentiate this, you will get, all right, dq by dt. Current is dq by dt. You will get that. Yes, yes. Very, 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 very important. So Murli, don't worry. Stay with me. Solve problems. Don't worry, beta. So we are going to solve problems today, tomorrow. When you practice these problems, slowly these formulas will stick into your head. Ravi, Meena and others, those who are asking for 11th portion. Guys, I conducted a lecture yesterday. There was a lecture yesterday for entire 11th standard syllabus, mechanics, SHM, fluids, thermo, waves, all of this was conducted yesterday. So please watch that lecture which I have conducted yesterday. Now let's get going to the next one. All right. Is C is equal to Q? Yes, Sakti, it will be Q, because in the previous slide, if I go, think about it. Oops. Yeah. This charge will be the capacitance into the battery's voltage. So that will be the final charge which will be stored eventually after a long time. Okay, cool. Now, again, very, very important. Hello, Mini Pahol, long time. Yes, joined in late, I guess. Current is J dot A, very important. What is this J? J is current density. This J is current density, very, very important. It's a dot product, current per unit area. Next, to find the drift speed, use this formula. I is NVIDIA. And what is this N? This will be generally given. It is number of free electrons per unit volume. Very, very important. It is number of free electrons per unit volume. A is area. What is this VD? VD is your drift speed. It's your drift speed. The speed with which the electrons keep drifting away. Very good, very good, very good. Keep this in mind. All right. So having said that, yes. Okay. So next up. All right. I hope you guys are noting it down. NVIDIA is a very, very simple way to remember. Yes, Sakti, you said it. It will be basically the graphics card company, NVIDIA. That's how you remember it. Current is NVIDIA. Correct. Next up, resistance. R is rho LA. R is rho LA. What is rho? Rho is resistivity. Resistivity. Keep this in mind. R is the resistance. Resistance depends on the length, area of cross section, and the resistivity of that material. Keep this in mind. Also, this resistivity or this resistance, you can say, depends on temperature, which is R0 1 plus alpha delta T. So with changes in temperature, resistance also changes. Keep this in mind. So this is the formula used. Okay. Now, a separate formula is for Ohm's law. Ohm's law is V is IR, correct? But you can also alternatively write Ohm's law as, instead of voltage, you write volts per meter. What is volts per meter? Field. Instead of current, current per unit area, that is J. And instead of resistance, you write the specific resistance, which is the resistivity. Resistance per unit length, per unit area and all that. So you will get resistivity. So E is J rho. Very, very important to find the field inside a conductor. Now keep this in mind. Guys. Inside a conductor, usually the field is 0. But here you are seeing the field is not 0. Why? Because the charges are not at rest. only when charges are at rest, only those times the field is zero. But when current flows, obviously the field is not going to be zero, and that can be calculated using this formula. Keep this in mind. Okay. Yes, so Rameshwar, this is an English channel, that's why Enthuse. Enthuse is the name of the channel, and just to make it very clear that this is for all the students who want to study in English, that's why we have added that word English out there. Okay, power loss, everybody knows I squared R or V squared R by R, but similarly, you also have power supplied by a cell or a battery, and that power supplied is EMF of the cell into current. So remember this formula as well. Correcto. Yes. So, well, Sakti, I think you should put it up in the comment section for Wasim sir's video. Definitely will read to all those comments, or probably just ping him on Instagram. Definitely. Yes. Cool. So do that. All right. So having said this, let's get going to the next one. Very important slide for series parallel circuit. Everything in one slide, guys, for all of you. Resistor in series, R1 plus R2 plus R3. In parallel, reciprocals get added. But for EMFs, this is how it looks like. For EMF, the effective EMF, matlab, each battery is connected one after the other. Effective EMF is E1 plus E2 plus E3 plus E4, but provided all of them are in the same orientation. If one of the battery opposes the current, then use that minus sign. So if all batteries support, then E1 plus E2 plus E3. If one of them opposes, E1 plus E2 minus E3, let's say. Similarly, if they are in parallel, use this formula, E1 by R1 plus E2 by R2 ... divided by 1 by R1 plus 1 by R2 plus 1 by R3. This is for parallel. One battery in parallel with the other battery, and together they give some current and voltage. The effective battery EMF is given by this formula. Alright. Next, capacitance. For series, 1 by C1, exactly opposite to resistors. I hope you see that. Exactly opposite to resistors. You can see that. Very, very important. Yes. And yes, Avantika, I'm going to cover the entire 11th standard syllabus today, beta. Yes, that's why it's a marathon session, and don't spam or else you'll get blocked. Come on, chill out. Yes. Mudit, don't worry. Just talk to, I'm pretty sure they are planning something. Don't worry, Mudit. All right? Don't worry. Yes. Now, tacholic sign convention in cells, I'll tell you what. I'll just give you an example. See, if it is something like this, okay? This is 3 volt, this is 2 volt, this is 5 volt, or maybe this is, 1 volt. So then the effective EMF will be 3 plus 2 minus 1, because this is opposing. That's how it works. But for parallel, all right, let's say this is like this, let's say this is like this, let's say this is like this. Okay, now let's say this is 3, 2 and 1. So when you use this formula, all right, so this E1 is going to be 3, this E2 is also going to be 2, but this is opposite, so this is going to be minus 1. That's the only change. Keep this in mind. Yes. Saurabh, that's not going to happen. This comes via derivation. So this comes after applying Kirchhoff's voltage law and Kirchhoff's current law, not otherwise. Okay, cool. Okay, and for inductors, it is just like resistors. Inductors is just like resistor. Yes. Okay, keep this in mind. Very, very important. So whatever concepts you apply for series, all right, you can apply for other things like current flowing through all the resistors is same. Here in capacitors, charges through all the capacitor is same. In inductors, the rate of flow, change of current through all the inductors is same. Correct? In parallel, the currents get divided. In capacitors, the charges get divided, and in inductors, the rate of change of current gets divided. All right. Next up, instruments. So, talking about voltmeter. Voltmeter, all right, it always has, very, very important, high, oops, one sec. Yeah, this has always very high resistance. They are always connected in parallel. And remember, for any problem of voltmeter or ammeter, treat the voltmeter or ammeter just like a resistance. That's it. Inside a voltmeter, what exactly is there? So if you see what is exactly there inside a voltmeter, it's nothing but a galvanometer, all right, plus another resistor in series. That's all. So this resistance is very, very high, so that the total effective resistance becomes very high. And what happens? The current ends up flowing, all right, the current ends up flowing through this circuit, and because this part has very high resistance, hardly any current will flow here, and it will not take much of current through that circuit. That's the whole idea of a voltmeter. Yes. Now similarly for ammeter, ammeter is always connected in series. Very, very important. Ammeter is always connected in series. Ammeter has very low resistance. And what exactly is there inside an ammeter? Inside an ammeter, it's nothing but a galvanometer, all right, with another resistor, all right, which is always called as a shunt resistance, and this is a very low resistance. Because of this shunt resistance, what happens is, when the current flows inside the circuit and it comes here, most of the current flows through this resistor, and hardly, all right, hardly any current flows through the galvanometer. So it behaves, because this is a low resistance, it is almost like a wire, so there is hardly any resistance. Keep this in mind. Very good, very good. Okay, I hope these two instruments are clear. And last instrument is very, very important. Yes, thank you, thank you. All right, everyone, very good, very good. Okay, so okay, one second. Yeah, in potentiometer, remember the easy trick to solve this problem, the easy trick to solve potentiometer problems is, see, if you take the battery's one side terminal as 0 volt, this side will have E volts, okay? Here there might be some drop, and maybe there is some change in the voltage, maybe it has some V1 voltage. So whatever V1 is there over here will be also present here. This is V1 volts and this is going to be E volts. So think this way, this is that potentiometer wire, and in that wire, since resistance is proportional to length, you will see the voltage will gradually increase from V1 to E. If at this point it is V1, at this point it is E, at any other point, simple ratio proportion, that's it, you're going to get it. Simple ratio and proportion, you're going to get it, that's all. Understand? So it's just at x equals to 0, voltage is V1, at x equals to L, voltage is E, at x equals to x, how much is the voltage? That's all. That's how it is. Another important thing that you should understand, if somewhere over here the potential is V2, when it is having null deflection, so when there is null deflection, very, very important, when there is null deflection, the current here is 0, and when the current is 0, understand the potential difference across PQ. The potential difference across PQ is the potential difference between A and this point B, and that is nothing but E minus V2. So E minus V2, whatever, that is exactly the potential difference between these 2 points. Very important formula. Keep this in mind. Okay, I hope this is clear. Yes. So galvanometer, Vatsala, is converted into ammeter just like the way I explained. So make sure that most of the current flows through the shunt resistance, hardly anything flows through the galvanometer, but at the same time the deflection because of that small current is still proportional to the current. So hardly any current is flowing, but that small current is enough to deflect the galvanometer, and it is proportional to that current. That's all. All right, cool. Let's get going to the next one. Okay. I hope this is clear, guys. Everyone, is this clear? Yes. Is this clear? Yes. And one more important thing. See, one more important thing. See, guys, whenever you want to find voltage difference between A and B, very important formula. Voltage difference between A and B can be found out like this. Think as if there is one resistor from A to B, all right, one resistor from A to B and another resistor from B to, let's say I call this point C, B to C. And whenever you want to find voltage across any one resistor, use this formula, it always works. It is the total voltage between points AC, total voltage between points AC, okay, divided by total resistance, which is RAB plus RAC, and into the resistance across which you want to find the voltage, which is RAB. That's it. This is the most easiest way of doing it. Most easiest way of doing this. And since resistance is proportional to length, you can also do this. RAB is only this length of AB, correct? And this resistance plus this resistance is the total length. So this is an easy way of doing the problem. Okay, clear? Oh my God, Gautam Jayant, very, very happy birthday. Wish you all the best. May you do well. Glad you are here. All right, cool. So, having said this, let's get going to the next one. Here are your questions, 2005 question. Come on, let's see how many of you do this. This should be done in 1 minute, not more than that. Thank you, Anuj. Okay, think. And guys, if you still have any doubts, you can always ping me on Instagram, and my Instagram handle has been already mentioned in the description box below, or you can also put it up as comments below the video after the video ends, because if you have noticed, I respond to all the doubts that you ask in the comment section after every one of my video. Very good. Yes. Come on. Think. Okay, Dinesh says B, Rupa says B, Nilobit Kashyap says C, Uday says B, Ganesh says C, Science, okay, B and C. Alternative, I mean, Sakti, I forgot, with reference to what, Sakti? All right. Achut, well, right now at least I'm doing English channel, be happy. Okay, so I'll tell you what has to be done, guys. Okay, the time is up. So the plates are something like this. And okay, and if this is first plate, this is second, this is third, this is n minus 1, this is n, and they are in parallel, all right, such that, okay, now this is very interesting. Every alternate plate is connected. That means 1 and 3 are connected. 3 and 5 are also connected. So something like that. Okay, so I don't know, I'm just guessing. So every alternate plate is connected, and same thing with 2 and 4. Similarly, all right, 2 and 4 is connected, and 4 and 6 is connected, and so on and so forth. So guys, do you see that every plate which has another opposite plate will form a capacitor? Do you see there is a capacitance formed over here? This is C, this is also C, and so on and so forth. This is also C. Do you see that every capacitance has the same voltage difference? Look at the voltage difference. If one has V1 volts, and the other side has, let's say, V2 volts, every capacitance has the same voltage difference. So can I say all are in parallel? If all are in parallel, what is the effective capacitance? Number of capacitors into each capacitance. Now be very careful here. The total number of capacitors are not n, it is n minus 1. Be careful. Yes, this is first capacitor, this is second, third, etc. So this is the n minus 1th capacitor. So it is n minus 1 into C. That's the answer. Yeah, so a lot of you said C, that is wrong. Be careful. A lot of people have got the wrong answer. No, it is not n, this is wrong. It is n minus 1. Be careful. Yes. Understood? Yes, B is correct too. Yeah. Let's get going to the next one. Yeah. So this is answer B. No problem. Happens. Yes, very good, Dinesh. Okay. Alikha, very good. All right. Let's see how many of you get this 2002 question. You should get this within 20 to 30 seconds, not more than that. Let's see how many of you get this. Come on, 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 come on. Let's see how many of you get this. So guys, remember today is a big session. The session might continue even till 10 o'clock. And just for all of you, I'm here. And remember, I'm going to have my food only after I complete this session. So if I'm willing to put that hard work, you have to also show that much of dedication, love and support. Come on. All right, all right. I'll tell you what, the correct answer is actually B. Very good. Many of you minions have got the correct answer because they are in parallel. These capacitors are in parallel. So the voltage difference across each one of them is V only. And each capacitor will have half CV square because voltage is same. But like that, there are N capacitors. So hence option B is correct. Very good, very good, very good. Let's see how many of you do this. These are rapid fire questions just to boost your confidence and also to show you that these kind of questions are actually asked in JEE exam. So don't think I'm kidding over here. No, I'm giving you actual JEE questions, actual bits questions, actual questions which come in JEE from NTA, from previous years, from my special collection. Come on, let's do this. Capacitance in farad for a spherical conductor. You should get the answer within next 30 seconds, not more than that. Thank you, Hitesh Kumar. Come on, let's see how many of you get this. Come on, come on, come on, come on, come on, minions. Do this quickly. Thank you, Achyut. Thank you so much. A lot of you are saying C. Well, you guys are wrong. You guys are wrong. You guys are wrong. You guys are wrong. Ravi Meena wrong. No, Dinesh, no, Princey, no, Arya. Okay. Wrong. The answer is actually A. That's why it's a JEE question. What did I tell you? See, I'll tell you how this comes. Now, when you have a spherical capacitor, alright, when you have a spherical capacitor, the capacitance is given by 4 pi epsilon naught 1 by A minus 1 by B, correct? That is the formula given. But if it's just one sphere, the second sphere is not there. So you can think of it as if the other sphere is infinity. It's the infinite boundary. All right, the second sphere is at infinity. So if second sphere is infinity, the capacitance becomes 4 pi epsilon naught 1 by A minus 1 by infinity. What is 1 by infinity? 0. So if this is 0, won't it become 4 pi epsilon naught A? That's it. Now substitute the answer value. So when you substitute the value, what will you get? 4 pi epsilon naught is 1 by 9 into 10 to the power 9. And A is 1 meter. So this is going to be careful, 0.11 into 10 to the power minus 9. And this is 1.1 into 10 to the power minus 10. That is option A. Yes, be careful. Yes, be careful. Be careful. Yes. That's how it is. That's how it is. I hope you guys have understood this. Understood, everyone? So be careful. Be careful. Yes, such a good question. And a lot of people fall for this. Let's get going. Remember, 1 upon 4 pi epsilon naught is 9 into 10 to the power 9. And janbujh ke, those examiners know what kind of mistakes you're going to do. And they have put options like this. Because they know you're going to make those mistakes. Okay. Chalo, next. There is an ammeter, 2003 question. Reads up to 1 ampere. Its internal resistance is 0.81 ohm. To increase the range to 10 amperes, what is the value of the shunt resistance? Let's see. Come on, think. Achyut, basically do not use calculators at home. You should know tables till 30. Also, you should know all the constants value. You should know square roots value and all those things. If you are in a habit of doing all the calculations at home by your own, then your calculation will automatically improve. Thank you, Anuj, so much. Okay, C or D? D. Kiani said A. Okay, Mudit says D. Music Time says D or C. All right. Come on, let's see what's the correct answer, guys. Well, I'll tell you what. See, the ammeter can read up to 1 ampere. That means this galvanometer can hold up to 1 ampere of current maximum. And what is the resistance? The resistance is 0.81 ohm. Now, in order to measure up to 10 ampere, what will you do? You will divert the current, and some of the current will go through the shunt resistance and it will come here like this. Now, how much actual current will enter inside? The actual current which will enter inside is 10 amperes, out of which you want only 1 ampere to enter inside the galvanometer. So the remaining 9 amperes will go through the side resistance, the shunt resistance. Keep this in mind. So this is 10, this is not 10. That's what the common mistake is. So guys, remember, resistance is inversely proportional to the current in parallel circuits. More resistance, less current. That's how it works. So R by 0.81 will be, alright, current flowing through R is 9, current flowing through 0.81 is 1. Inversely proportional, you can see that. So R will be 0.81 divided by 9, which is 0.09 ohms, which is option D. Amazing, amazing. Clear? Hello Tela Iswar, welcome. Hello Manju P, welcome. Very good Hatim Ali. Hello Radhi 27212, Mas. I'm not sure what it means. All right, Sakti, you're correct. Oh boy. Correcto, correcto, correcto. Very good, very good, very good. Let's get going, guys. I hope you guys are enjoying the session and I hope you have already smashed that like button. If you have not done it, do it right now. And if you are new to the channel, go hit the subscribe button, because we are going to discuss all the papers on this channel of JEE Mains next week for you. If you want to show your support and love, you should hit the subscribe and the like button. And guys, let me tell you, today we're going to discuss all the formulas, important concepts with problem solving in this marathon session. Come on, gear up. Yes, you have to stay, because I'm pretty sure you're going to replay this session at least 3-4 times before the JEE Mains examination and even for the next attempt of the JEE Mains. Yes, you're going to do that. I know that. And come on, get your friends also to this channel, because you have to be like our mascots. You have to be our superheroes, the small superheroes, the ones who are here are all our loved ones who are going to get all your friends. That is your Guru Dakshina for me on this channel. See, I'm not asking you any money. I'm doing all this for free. I could have chilled, relaxed at home. I could have watched a movie on Friday, but I'm not doing that. I'm here only for you because I want this channel to grow, and I'm pretty sure you also want this channel to grow. Yes, let's do this. Let's do this. Next question coming up on your screen. 220 volt, 1000 watt bulb is connected across 110 volts supply. What is the power consumed? Come on, let's see. 20 to 30 second question. This is 20 to 30 second question. So what basics you need for electricity? Well, you need the basics of electrostatics and little bit of maybe Gauss's law. Apart from that, nothing much. All right. Yes. Oh, nice one. Tricky one. Trickypedia. Good one. All right. Come on, come on, come on, come on. Yes, very good. Power Rangers. Nice name. Yes, Sakti. B arc paper will also be like the BTech paper. Many of you are saying B. Some of you said C. Okay. Well, I'll tell you what. In such kind of questions, all right. So it's the resistance which is the same. So first, you are connecting it to 220 volts and the power is 1000 watts. Now remember, power is V square by R. So R is V square by P. Now next time, when you use the same resistance, that has not changed, but the voltage is 110 volts. What is the power? That's the question, right? So just use this and you will get the answer. V square by P. V square earlier was 220 square by power, which is 1000, is equal to new voltage 110 square by the new power. Now do the math. Power will be 1 by 2 square into 1000, which is 250 watts. There you go. Option C. Well, some of you are wrong. Some of you are wrong. Okay, come on, be careful. Yes, this is how you need to do this, guys. Be careful. Yes, it is V square by P. Understood, understood, understood. Yes, C is the correct answer. Many of you said B. I don't know why you said that. You thought voltage becomes half, so power also becomes half. Wrong. That is how IIT exam setters, paper setters are going to trick you. Be careful. That's why I'm making sure that when you attempt these questions, you will realize your mistakes and your performance will be boosted at least by 10 to 15 marks just by attending today's session neatly, completely, making notes. Full dedication you need to attend today's session. Let's go to magnetism. Let's go to magnetism. Very good. Sekaramam. Very good, very good. Don't worry, Murli. See, that's why you are here. If you don't get the answers to the question now, that means you are learning. Very good. In fact, you should feel proud that you are learning. If you are understanding, that is something which is very worthy and should be appreciated. All right. So, creative Girish, like I said, it will go until at least 9-10 o'clock. Biot-Savart's law. Biot-Savart's law. Mu naught by 4 pi IDL cross R by R cube. This is R cube, guys. I don't know why it's R raised to Z. Okay, let me just make it R cube. Okay, so if you are near a conductor which is carrying current at a distance of R, the magnetic field is given by, due to a small element dl, mu naught by 4 pi, alright, mu naught by 4 pi IDL cross R, alright, divided by R cube, alright. So this is R bar, this will be R cube. Keep this in mind. Alright, alright. And some people also write this formula like this: mu naught by 4 pi IDL cross R hat divided by R square. Because remember, R hat is R bar by R. So take one of the R's, so only R square will remain. So you can use this formula also. Next up is Ampere's loop law. Next up is Ampere's loop law. Hello Revolution Gaming, welcome. If you have wires carrying current, alright, wires carrying current like this, I1, I2, I3, alright, I4. If you take a loop around those wires which carry current, around that loop which carries current. So this is basically called as an Ampere loop. This is a loop. Then B dot dl. B dot dl means magnetic field at every point dot dl. So at every point you move ahead by some dl amount, and at every point there will be some magnetic field. So B dot dl's integration across the loop once gives you mu naught into current enclosed. Here, what is the value of current enclosed? Now be careful. Only I1, I2, I3 are there. That is what is enclosed. I4 is not to be counted, just like Gauss's law. But sign convention is very important. Curl your fingers in the direction of the loop. How is the loop going? Like this. See where your thumb is going. Like that. So these two currents are positive. So it will be I1 plus I2, and this is negative, minus I3. So that is the value of the enclosed current. Yes. So Veena, just like in Gauss law, you take the dot product of field with area vector. Here is the dot product of the magnetic field with the length vector. So what happens is basically you keep traveling across that loop, and at every point there will be some dl, and at every point there will be some magnetic field. The B vector dot dl vector gives you mu naught into I. What is this used for? This is used for calculating magnetic field. You don't have to do this integration. If you see the NCERT or derivations in H.C. Verma, you can find out magnetic field due to different geometries using this. Yes, Alaya, Tanmay, yes, this is also useful for NEET BITSAT preparation as well, because physics is the same, formulas are the same. Okay, so Velugula, what are the basics for class 12th? Very simple. You need class 11th beta, nothing else. As simple as that. Okay, now using Ampere's law, you get the magnetic field due to all these geometries. What kind of geometries? Number one, due to a long wire carrying current. So just to give an example, if you go around this loop by dl amount, magnetic field is also in the same direction. So if one were to use B dot dl is mu naught into I. So if somebody goes across this path which has some radius r, then understand at every point B and dl, alright, the angle between them is 0 degrees. So cos 0 will be 1. So when you take cos 0 as 1, it will just become B dl, that dot goes away, cyclic integral mu naught into the current which is inside, which is I. Then what else do you get? B is a constant everywhere because you are at the same distance. So B also comes outside and you will have cyclic integral dl, which is mu naught into I. Now the integration of dl, that means addition of all the paths once, what is it? It is nothing but 2, what is it? 2 pi r is equal to mu naught I. I hope this is clear. That's how you apply Ampere's law. That's how you apply Ampere's law. Very good. And from that you get the value of B. Yes, the value of B is nothing but mu naught I by 2 pi r. Very important formula. Okay, keep this in mind. Yes, very good, very good. And similarly, for a circular loop, the formula is at the center, very, very important. If you are at some distance x, then the magnetic field formula, very important guys. What is the magnetic field formula? The magnetic field formula is mu naught I, keep this in mind, by 2 r, usually when you are at the center. But if you are at a distance x, then it is r square plus x square whole raised to 3 by 2. Okay, mu naught I by 2, r square plus x square whole raised to 3 by 2. This is what is very important guys, and keep this dimensionally consistent, so you will have an r square on the top. That's it. This is the formula on the axis of a current carrying loop. Very, very important. Yes, very, very important. So Tela Ishwar, just refresh your screen. I hope that will solve the problem, or just check your internet connection once. Just close the tab and come back again. All right. Next, for a toroid and for a solenoid, inside a solenoid, what is the formula? B is mu naught Ni. It's very simple. What is this N? Turns per unit length. Turns per unit length. Very, very important. But for a toroid, inside a toroid, what is the magnetic field? It is the same thing. Just that here you have turns per unit length, right? Now here you have turns upon this length. Here the length is the circumference. So it is total turns by 2 pi r into current. So the only difference here is this N stands for the total number of turns, and this R is this radius. This radius is nothing but R. Keep this in mind. Yes, I hope this is clear. Very, very important. Very important. Yes, I hope this is clear. Come on guys, let's keep the Josh high. Yes, yes. Karthi, tomorrow's class is most important questions. It is going to be a mock test discussion. We have created a mock test. We'll be sharing the mock test with you on the Telegram group. You'll be solving it and we'll be discussing the mock test tomorrow. Okay, come on. Let's get going. Okay, guys, are you tired? I'm not tired. Are you tired? How many of you are tired? Tired? So fast. How are you going to write 3 hours examination? Think about it. It's hardly 1.5 hours over, and we have to maintain the spirit, because if you cannot sit for 3 hours continuously, trust me, you cannot sit for 3 hours in the actual examination hall as well. In fact, you don't just have to sit over there. You have to be alert. You have to think continuously for 3 hours. So do you imagine the stamina which is required? So we are making sure that we build up stamina for you. Okay, let's do this. Magnetic force. Very good, very good. Josh is high. Excellent, Geeta, Duraj, Vatsalya, Sandeep, Yalni, Modit, Sans Priya. Very good, very good. Sakti, 100 out of 300 will be very low rank. But I feel that if you follow my techniques, you should get minimum, even if you are zero, if you are, let's say, zero before you started attending my classes, you will score minimum 150 marks if you have been following my classes regularly. Minimum. If you are already at 100, you will score more than 200, trust me. Thank you, Alaya, so much. That means a lot. Well, these are the formulas. Next formula. Charge thrown in magnetic field. What is the formula? QV cross B. Keep this in mind. QVB. QV cross B. Whereas current carrying wire in a magnetic field is also like a charge which is moving in a magnetic field, because current is nothing but flow of charges. It is IL cross B. IL cross B, that is called as Lorentz force. Yes, keep this in mind. All right, IL cross B. Now there is very important thing over here. See, this formula is very useful for when there is magnetic field and there is a charge which is thrown and it goes in a circular path. All right, the radius is mv by qb. Very important formula. Keep this in mind. Charge is thrown, it goes in a circular path, the radius. Very important. Another important thing that you should know is that, yes, there is a very interesting theory pointer for this formula, a shortcut, and I'm going to show that to you in a problem. There is a very nice shortcut trick for force on a curved wire. What is the force on a curved wire? I'm going to show that to you in a problem, so wait for that. All right, let's get going to the next one. All the three important cases for a magnetic dipole in a field. If there is a magnet inside a field and it is parallel to the field, the torque is zero. It's just like electric dipole, in case you remember. I just talked about it. Remember, torque is dipole cross field. So exactly similar, and potential energy is minus m dot b. Very, very identical. If it is parallel, torque is zero, energy is minus mb, because angle is 0 degrees. Cos 0 is 1 and that minus sign comes. This is stable equilibrium. So if a magnet is placed here and if you tilt it, it will come back. If you tilt it, it will come back. Just like a magnetic needle in Earth's magnetic field will always come back in the field's direction. If you keep it perpendicular, it's definitely not going to be happy. There is going to be a torque acting on it which will rotate it. Energy wise, 0, because dot product is 0. It's not in equilibrium for sure. If you turn it opposite, torque is 0, but it is unstable equilibrium, because if you tilt the magnet even little bit here and there, it will flip that side or it will flip that side. So it is in unstable equilibrium, and since the angle of the dipole and the field is 180, so the dot product will be negative. Negative of negative will be positive. So keep this in mind. Yes, I hope this is clear. Yes, Naga, I hope this is clear now. No problem, Shreyas, Kohike, no problem. You can leave that, but trust me, it is simple. But don't worry, after the first attempt, we'll be doing some special classes for transistors, semiconductors, and logic gates, and also communication systems. Don't worry. Okay, cool. Let's get going to the next one. Remember these formulas and remember this slide. Very important kind of questions. Object in external field. So just like when you place a dielectric in somebody else's field, the dielectric gets polarized and the field inside the dielectric changes. Same way, if you take a material, maybe ferromagnetic, diamagnetic or paramagnetic, that material gets magnetized, because of which, apart from the external field, you also have the induced field. So the net field inside is the external field plus the induced field depending on the material type. If it is diamagnetic, then this induced field is opposite. If it is dia, the induced field is opposite. If it is para or ferro, the magnetic field is in the direction. For para, the magnetic field is small, but for ferro, the magnetic field is very strong. Keep this in mind. Yes. Now, having said that, some more important formulas coming up for all of you. The entire magnetic properties formula on one slide. Write it down. Come on, do this. Do this. Glad to know that, Jagdish. Very good, very good. Yes. Definitely it's going to boost your marks. Thank you for all the love and support, guys. Diya, how much marks should you score for CS in NIT Silchar? Well, I'm not sure of our NIT Silchar, Diya, right now. But for computer science, your marks should be really high. I'm pretty sure. And it depends whether it's your home quota or not. Generally, for computer science, you should have at least 66% to 70% score to get into a NIT. At least, I'm saying. That's if it's a 300 marks paper, so it should be at least 210, 20 plus. Bharat, we are going to continue for more one and a half hour. Okay, cool. I hope this is clear. Yes, Naga. Yes, that much marks you should score. Correct. So one more thing, by the way, now don't keep asking, sir, for this branch how many marks I should score, for this branch how many marks I should score. This is the worst mistake which students do, and you know, many coaching institutes are to be blamed for this. Many coaching institutes do this in quota and all that. Ki, acha, if you want to get into this NIT, this IT, acha, then they do counseling. Acha, you should score this. Guys, you cannot do counseling. You cannot talk about branches before the exam. That's the worst thing you can do to a kid. Never do that. Please understand, right now you are not in a position to choose a branch because you do not have the report card, you do not have your rank. We can talk about branches, etc. only when you get your report card, when your rank is known. Till that time, you have to think that I am going to get All India rank 1. I am going to put in my best. I am going to score full marks. I don't care about which branch. We will see what happens. First, let me try my best. Do that. Yes. Okay, cool. Now, I hope you have noted this down. So that's why I was talking to all of you meanwhile, so that you have noted all these things down. Yes. Well, Ansdeep, well, I'm guessing it's too early for you. All right. So, but glad you like it. Yes. So Mudit, like I said, qualifying marks, usually it's around 100. So 100 is a safe bet. Okay. Cool. Very good, Shreyas and others, for reporting the virus. Let's see how many of you do this question. Come on, minions. Not more than 30 seconds. Not more than 30 seconds. So Hitesh, virus is something who is trying to spam or who is trying to create nuisance in the class. So we call them as virus. Okay, come on. Yes, let's do this. Some of you are saying 4. Some of you are saying D, which is 0. Okay, very interesting. Let's see, guys, what the correct answer is. Okay, 4. I don't know. Let's see. See, guys, it's a semicircle. How much current is it carrying? 2 amperes. What is the radius? Radius is 1 meter. Now I'll tell you what, the trick is, whenever you have a curved wire, all right, carrying current, and you want to find the force, replace that curved wire with a straight wire. Yes. Whatever force is applied on the curved wire, the same force is applied on a straight wire. That's the trick. That also means if it's a loop, then the force acting will be 0, because when you replace it, you'll replace it with a dot. Basically nothing. So force is 0. So very important trick. Now I'm pretty sure you have guessed it. So replace it with a wire whose length is 2 meters. So what is the force? I, L, B. Magnetic field 1 Tesla. So hence the answer is 4 Newton. Correcto. Very good, minions. Very important trick. So this was the trick I was just talking about. For curved wires, replace it with a straight wire. Keep this in mind. Yes, that's the answer, 4 Newton. Excellent. Let's go to the next one. Let's see how many of you get this. Yes. Let's see how many of you get this. The magnetic field at a point due to a small element of a current carrying wire is proportional to whom? So because of there is a wire and there is a small wire element. So because of that, at a distance r, what is the magnetic field at this point proportional to? Come on. Let's see how many of you get this. Come on. A, sure. Thank you, Lamita Chandrasekhar. Glad to know that. All right, very good, minions. Excellent. No, Bhavika, it's not D. A lot of people also think D. No, it's not D. It is actually A. See, you might think it is r cube. Well, let me remind you that formula. That formula is mu naught I by 4 pi dl cross r by r cube. You might think there is cube, but guys, do not forget there is a r here. One of the r's will get cancelled. Understood? So actually this dl cross r will become dl r sine theta, right? So do you see one of the r gets cancelled and you will have only r square below. So that's why inversely proportional to the square of the distance. Keep this in mind. Okay, let's get going to the next one. Yes, correct Shreyas Kuike, correcto. Alright, let's get going to the next one. Let's see how many of you get this. When a current loop is placed in a uniform magnetic field, which of the following is true? Which of the following do you think can be true? Which of these force is 0, torque is not 0, force is not 0, torque is 0. Which one do you think? Yes, Techolic, I know that. Even I have read so. Come on, don't worry about it. You guys should enjoy your childhood, but at the same time, you should also prepare for IITs and the topmost colleges at the right time. And this is the right age for preparing. Don't worry. Okay, come on. Let's see how many of you get this. A or B? All right. Hello, Siva. Welcome. Join in. And those members who are joining in, we are revising the entire 12th standard syllabus in today's session for the upcoming JEE Mains first, second, third and fourth attempt. You can play this lecture 100 times and this will act like a revision lecture. Those of you who have missed the 11th standard revision, watch the past videos. We have done the entire 11th standard syllabus yesterday. It's again a marathon session. And do not forget to hit the subscribe button. And if you have not yet liked the video, go hit the like button out there. Okay, a lot of you are saying A, and that is the correct answer. Very good. Remember guys, whenever there is a loop, all right, carrying current, but it is placed in uniform field, then remember there are two options. Remember, torque is M cross B. All right, torque is M cross B. So understand the torque depends on the angle between the magnetic moment and the field. So if theta is 0, torque is 0. If theta is not 0, then torque is also not 0. But the force, no matter what, force is always going to be 0 because of this word uniform. Yes, because of this word uniform. Trust me, if it was mentioned non-uniform, or if this word uniform only was not mentioned, let's say this word uniform is not mentioned, then what do you think the answer will be? So Anshdeep, the thing is, when you have a current carrying loop, right, there is magnetic dipole moment, M bar, okay, and that magnetic dipole moment is given by number of turns into current into area, and there will be also magnetic field. So that's how it is. So the torque is M cross B. So it depends what is the angle. I hope that makes sense. Is that clear? Come on. I hope Anshdeep that is clear. Yes, Aishwarya has got it. Very good. Hello Pradeep Thakur. All four of them can be possible. All four of them. Because I don't know whether it is uniform or non-uniform. When it is non-uniform, anything is possible. Force can be 0, not 0. Torque can be 0, not 0. Anything is possible. You do not know that. Yes, that's the correct answer. I hope this is clear. Okay, so remember this word uniform is very important. Yes. So is the magnetic field produced by the current, is it cancelled out? Karthi, some places it might, some places it can't. So it depends which point it will cancel out. So it depends on which point you're talking about. Next, let's go to EMI. Electromagnetic induction. Faraday's law is d phi by dt, rate of change of flux causes electricity which is induced. Now, how does flux change? Flux change can happen because of three things. Number one, B changes. Yes, magnetic field changes. Number two, angle changes. Angle changes. Number three, area changes. So any of these three things can change because this phi is nothing but B dot A, which is nothing but BA cos theta. So either B changes or angle changes or area changes. Any three of these things can produce flux change, which in turn can cause induced EMF. Keep this in mind. All right. Albert, Achyut, I'm very good. Thank you very much. Yes. Next up, what is the direction of this induced EMF given by Lenz's law? So Lenz's law says that the induced EMF always will oppose the change in the flux. For example, say there is a loop. Keep this in mind. If this is a loop, earlier the magnetic field was this much. All right, some field lines were passing. Now some more magnetic field lines come. So if the flux increases like this, the current or the induced EMF will oppose the change. Where is it increasing? Here. Opposite to that is down. Hold your right hand thumb downwards. See how your fingers curl. So the induced EMF will be in that particular direction, opposing the change. Keep this in mind. Thank you, Abhi Nambyar. Glad to know that. Yes, Shreyas, Kulike, angle between the magnetic field and the area vector. Correct. Yes, it is the angle between magnetic field and the area vector. Yes, keep this in mind. All right, so that's how you use Lenz's law. Hello, Ram. Welcome. Thank you, Avi. Glad to know that. It really makes me feel proud and really happy that you guys feel so. And motional EMF, very important formula. The induced EMF is L dot V cross B. Not many people know this. They just had BLV. But JEE Mains has asked questions where length, magnetic field, velocity were at angles, and many people didn't know how to do it or got a wrong answer because it never knew it is a dot and a cross product. L dot V cross B is the induced EMF when you move a conductor in a magnetic field with some velocity. Yes, this is so Sakti, for everything I use right hand, so I never use left hand for anything. So that avoids any kind of confusion. Never use left hand, always use right hand so that things are very clear. Okay. Hello Nagendra, welcome, join in. Okay, one more important thing that I would like to mention over here. If it's a curved wire, all right, and that curved wire is translating with velocity v, then the induced EMF across its ends can be found out by replacing it with a straight wire. Replace it. So a straight wire has the same EMF as a curved wire which is translating. Keep this in mind. Can be useful for so many cases and can simplify things by a big deal. Hello Nishant, welcome. Hello Ruchi Chobe, welcome. Yes, so can I again explain the right hand palm rule? See guys, if for example this was a loop, let's say, all right, I do not know how the current is going to be induced. Say for example, let's take some other case. This was the magnetic field before. Now, let's say the magnetic field reduces. So guys, think about it. If this magnetic field B is reducing, if it is reducing, what will happen? According to Lenz's law, because it is decreasing, the EMF should help it. It will strengthen it. So because it is reducing in this direction, it will strengthen it because it was reducing. So how do you strengthen it? Use your thumb in that direction along which you want to strengthen it, here. So place your thumb there, your fingers will automatically curl like this. So understand your current is going to be induced in this direction. Is that clear now? I hope this is clear. Yes. Mintu, this started at 7 o'clock, but don't worry, whatever you missed, you can watch the replay. Whatever is remaining, watch it live, and whatever is remaining, watch it as a replay. Yes. Cool. Let's get going to the next part. All right. Okay. Inductance, very important. If two coils are there, all right, they have two kinds of inductances. Yes, two kinds of inductances. One is self-inductance, one is mutual inductance. So, understand mutual inductance. All right. So mutual inductance means if the current in the primary changes, that creates EMF in the secondary. That EMF in the secondary is given by M di by dt. Very important. The EMF in another coil is created because of the changes in the current in the primary coil. So M di by dt. Some books put minus symbol, but we understand that minus is because of Lenz's law. We are just talking about magnitudes here. Similarly, understand the flux in the secondary is also given by Mi. So in fact, when you differentiate this derivative, when you take the derivative, that's what you get. Very, very important. When you take the derivative, that's what you get. Yes. So Mintu, I'll give the PDF, but you are not going to get whatever I'm going to write on the screen. So that's why you need to make the notes and watch it. All right. Yes. Similarly, if you just have a coil which is carrying current, the self-inductance is given by Li. What is this phi? Flux because of that own current. This is the flux because of that own current that is going to give you the self-inductance, and that d phi by dt is going to be L di by dt, magnitude wise. This is self-inductance, very, very important. So this one is for self-inductance. Keep this in mind, guys. All right. Very good, very good. Sure, Anu, why not? Why not? Yes. Very good, very good. All right. So let's go ahead. Anu, don't spam, don't worry. We'll ask. All right. Other teachers as well. All right. Cool. No problem, Techolic, but watch the remaining part. Else, trust me, you're going to miss few marks. I don't know. Yes. Now, next up, EMF created. The EMF created because of a coil which is rotated in a magnetic field. We are slowly moving to AC circuits. Come on, guys, we are doing great. We have hardly a few things left. Let's do this. Come on, let's do this. Okay. So, the EMF generated in a coil which is rotating is given by Born sine omega t. That's it. Born sine omega t. Very important. Remember the word Born. And if you have seen Born Identity and those movies, it's very easy to remember that. Omega is angular speed, N is turns, A is area of the coil, B is the magnetic field in which it is rotating. Keep this in mind. All right. Now, similarly, next up, RMS value. Very important. RMS value, be it RMS current or RMS voltage, it is the maximum voltage divided by root 2. Remember this, maximum voltage or maximum current divided by root 2 is going to give you RMS. And average value of AC is always 0. Keep this in mind. Average value is 0 because amount of positive and negative is same. So the average value will always be 0. Keep this in mind. Yes. Oh my God. I hope Vatsalya, Thanos, things improve a little bit. All right. Watch it in lower resolution if you can. Yes. All right. Now, if this much is clear, let's go to the next one. Power loss in AC. Very important, guys. It is IRMS square. Lot of people miss this word RMS. Be careful. It is IRMS square into R. Keep this in mind. IRMS square into R. And alternatively, you can use this formula as well. And that is nothing but VRMS. All right. IRMS into cos of phi. What is this phi? It is nothing but the phase difference between the voltage and the current. Very, very important. You can use either this or that formula. Both will work. Remember that. Okay. Keep this in mind. Power loss in AC circuit. Okay. Very good. So RMS is root mean square beta. Oh my God. Arvind sir is also here. Nice to see all of you. Okay. Thank you, Arvind sir, for being here. All right. And also remember, guys, that RMS definition, the definition of RMS is value 1 square plus value 2 square ... divided by n. Yes, that's how it is. Root mean square. So what is the meaning of RMS? If you're wondering what is the meaning of RMS, I'll tell you what it means. If you have a resistor Imagine if you have a resistor and you pass AC voltage across it. You are passing AC voltage across it. It will develop some heat. But the problem is that heat which will be developed will be variable because the current or the voltage is changing. So that current, that DC voltage through that same resistor which will produce the same heat, that DC voltage is called as the RMS voltage. And that RMS always comes out to be this Vmax, alright, this Vmax divided by root 2. That is the meaning of RMS. I hope this is clear. Yes. Cool. Oh my god, Priyanka, I hope it becomes better with time. Alright, let's get going to the next one now. Okay, come on guys, we are nearing to AC, then we have just modern physics and optics and YDAC left. Come on, let's do this. Let's do this. Okay, phasor diagram. Remember this very simple technique. The resistance, inductive reactance and capacitive reactance can be drawn on a phasor diagram this way. Inductance is always on the top. Remember, love is above all. Remember this phrase. L stands for inductance. If you remember this phasor diagram, that's it. You're sorted. XL is omega L. XC is 1 by omega C. Keep this in mind. The phasor rotates like this. And the resultant of all these three vectors is going to give you Z, which is nothing but impedance. And you can see the vector Z is actually this vector minus this vector. So XC minus XL. Alright, that's in Y direction. And in X direction you have R. So Pythagoras, use Pythagoras, you will get this impedance. That's how you do this. Alright. Sarthak, patience beta, patience. I'm going to do everything. Sarthak, patience. If you're going to act impatient like this, trust me, it's not going to work. Rome was not built in a day, beta. Alright. Next up, what is impedance? Impedance is the total resistance of the circuit, effective. So capacitor and inductor also give some resistance in AC. That is called as the total effect of resistance is called as impedance. So capacitance, inductance and resistance together. But they are not in the same phase. That's what you need to keep in mind. Next up, for voltages also you have same thing. Remember for voltages also. So you have VL here, you have R here and you have VC here. What is VL? VL is I into XL. What is VC? It is I into XC. Alright. And oops, sorry, this was VR. So VR is I into resistance. So when you take the resultant of all of them, you get the total voltage across the circuit. The total voltage across the circuit, and that is current into Z. You can see the previous triangle when multiplied by I, you get this. The previous vectors when multiplied by I, you exactly get this. So that's how these triangles are similar. Very, very important. Yes. So current through all of them will be same. Yes, current through all of them will be same. Okay, I hope this is clear. Yes, Chandresh, that's why I'm doing this revision session so that it will be enough for all of you. Yes, let's do this, guys. Come on. Okay. So coming to LC oscillations now. If you have an inductor and a capacitor, okay, it is, and if it is charged, then the charges will go back and forth, and that is called as LC oscillation. Capacitance is similar to 1 by spring constant. Inductance is similar to mass. Keep this in mind. That's why time period, which is 2 pi under root m by k, you can see, replace mass with L, replace k with 1 by c, you will get this formula. A spring mass system, this is equivalent to a spring mass system which is oscillating back and forth. So if you charge a capacitor, it will get discharged, charged, discharged, charged. That is called as LC oscillation. That's the time period and the frequency of that LC oscillation. Keep this in mind. Yes, very, very important. Very, very important. Yes, keep this in mind. Okay, okay, okay. Great, great, great. Now, very important. Next up, if you connect this LC oscillator to a AC source, it can resonate only when the AC source frequency matches with the LC circuit's frequency. So that is called resonance. When the AC source's frequency matches with the circuit's natural frequency, that's when it's going to resonate, and that's when the current developed is maximum. If the frequency outside is not matching, the current produced in the AC circuit will not be maximum. All right, keep this in mind. Now, okay, one more thing before we go ahead. Remember, at resonance, keep this in mind. The phase difference is 0, current is maximum, power is also maximum, and in fact, XL is equal to XC. So in that phasor diagram, keep this in mind. Resistance will be here, XL will be here, and XC will be here. They both will cancel out each other. So the total impedance will be the resistance. Keep this in mind. Yes. So when the when the resonant frequency becomes minimum, well, I'm not sure, Vaibhavi, what do you mean by that? See, resonant frequency cannot be changed unless you change the inductor or the capacitor. AC circuit frequency can be changed by providing a different source. When you use a different source, the external frequency can be made 0. And when you make it very close to 0, it will behave like a DC circuit. And in a DC circuit, we know a capacitor blocks the current, and that's why no current will flow. I hope that answers your question, Vaibhavi. All right, let's get going to some questions coming up on your screen. Okay, Sabarshis, we have done kinematics last lecture, 11th standard revision was done. So watch the previous video. Come on guys, let's see how many of you do this. How many of you can do this? Oh my God, Yalini and then Priyanka. My God, what has happened to your net connection? Please, please, please. God, I hope the internet connection improves because this is such an important class for everyone. Okay, okay, okay. Come on, come on, come on, come on, come on. Subhash, watch my playlist on electrostatics magnetism. Make it stronger in the last few days if you can. Okay, I have created a playlist. All right, it's there on our channel. Do this. Come on, a lot of you are saying B. Srijal, Anshdeep. All right, Harish. Hello, welcome. Come on, 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 come on. All right, Sobia says B. Well, let's see what the correct answer is. The correct answer is actually D. I knew this. Many people are going to get it wrong. See, the flux is 500 microweber. So EMF generated is change in flux upon the time. Now, how much is the flux actually speaking? It is 500 into 10 to the power minus 6 because that micro word is there. There are 200 turns, so do not forget to multiply by 200. Now here is the catch. Look at this word reverses. So earlier if the flux was here, now the flux has been reversed. So guys, the change in flux is initial flux minus the final flux. So it is actually 2 times of 5. Be careful, be careful. It is twice. So do not forget that into 2, and then time taken is 20 into 10 to the power minus 3. That is going to give you the answer as 10 volts. Be careful. Yes, that's how it is. Be careful. Yes, understood. Yes, that's the answer, guys. 10 volts. So a lot of people forget that 2. This 2 is very important because reversed means final minus minus initial. So that's why 2 times. Yes, be careful. That's why these questions are very important for you guys, because I'm going to make sure that you brush up on all the concepts now. Yes, I know, Shreyas, happens. Next question. How much, an EMF of 5 volts produced by self-inductance when current changes at a constant rate from 3 to 2 amperes in 1 millisecond. The value of self-inductance is, let's see how many of you get this, 30-second question, not more than that. Nice to see Srijal from Nepal. Glad that people from Nepal, welcome, are also here. Glad to see. Yes, Srijal, you should get more people from Nepal to this channel because this channel is in English. I'm pretty sure many of you Would love to prepare for JEE in English. No problem, Nishant, happens. Thank you, Kalgara. Thank you so much. D, A. A lot of you are saying different things. Hello, Mallikarjun Temple, you're Noor, welcome. All right, Savarshis, glad to know that. Sobia says B. Well, let's see what the correct answer is. See guys, use this formula. The EMF is L di by dt. The EMF is already given 5. L I don't know. Change in the current 3 minus 2. Just look out at the magnitude. So 3 minus 2 upon the time. Time is 1 millisecond. That means 1 into 10 to the power minus 3. So L is going to be 5 into 10 to the power minus 3, which is 5 millihenry. That's the answer. Be careful. Yes, that's the answer. Yes. Bhuvana, don't worry. We are going to conduct special problem sessions. Tomorrow there is a mock test discussion. Many important problems coming tomorrow. Also on Monday and also after JEE Mains. Also we are going to have many mock tests. Do not worry guys. We are there for you. Next question. Let's see how many of you get this. Come on, come on, come on, come on. Very good. Nice to see you, Yalini. You're back. Very good, Viraj. Hello, Sasidhar Nagareddy. Welcome, welcome. Okay, come on. No problem, Sabarshis. In a series LCR circuit, voltage, amplitude V0, algebraic sum of the potential difference across capacitor and inductor is when the angular frequency is 1 by root LC. Come on, come on, come on. Anjdeep says A. Okay, come on, come on, come on, guys. Let's see. Some of you are saying it's B. I'm not sure. Well, the important word over here is this. When this happens, understand the source frequency is exactly equal to the natural frequency. And when this happens, it is basically resonating. And when it is resonating, do not forget VL and VC and this VR. This VL and this VC are equal and opposite. So when you add VL and VC, you should get 0 as the answer. That is correct. Yes. Oh my God, Tuluri Kinera. Oh my God, you're my old student. Where have I taught you? I would be very happy to know where I have taught you. And welcome over here. Hello. All right. And the correct answer is A. Okay. I hope this is clear, minions. All right. Yes. Correct. Let's get going to the next one. A transformer is based on the principle of which of the following? Come on, come on, come on, come on, come on. Don't worry, Muhammad, that is now in the omitted syllabus. Don't worry about that so much. Yes, it's not there in the compulsory one. Got it. Very good, very good. Thank you for all the love. Okay, A. Excellent. That is correct answer, minions. Very good. See how the chat box is flooding just because I gave a simple question, and these kind of questions have been asked in BITS exam also, guys. Can you believe that? Yes. I mean, like, really? Yeah. Anyways, now let's go to optics. Come on, quickly, let's revise all the concepts of optics. Everybody knows angle of incidence, angle of reflection equal. All these three things are in the same plane. And remember one thing, I dot R cross N is 0, always. I dot R cross N, angle of incidence, incident ray, reflected ray, and normal ray. If you take the scalar triple product, it is always 0. Okay. Now, this is also valid for a curved mirror. Keep this in mind. So every curved mirror acts like a plane mirror. So this is a normal, this is angle of incidence, reflection. This is a plane mirror, this is normal, angle of incidence, reflection. And the mirror formula is 1 by V plus 1 by U is 1 by F. Standard formula, remember this. Going on to the next slide, come on, let's do this. Okay, you should be able to draw the ray diagrams for any kind of mirror, for any kind of position. If you are interested to do that, do not forget to check out the playlist of optics. So I'll just show that to you just in case. So guys, this is how you can go to any lecture. So in the playlist, if you just go below, you can see that there is, if you just click on playlist over here, you can go down and you will see maths, physics, chemistry, everything has been arranged. If you open up physics, for example, you can find all the important playlists out here. All right, see, mirrors related playlist, all the important classes are there, and you can yeah, it's there over here. You can see all the important lectures, prisms, single slit reflection, etc. And in every video you will also see, all right, you will yeah, in the description box you can also open the session PDF, guys. You can see that session PDF, and you can get all the important formulas, etc. in this session PDF. Very, very important. So I have also given all the important ray diagrams, etc. in this session PDF. Keep this in mind. So do check it out later on, not now. So do that. All right, let's get going then to the next set of formulas. And there we go. I just told you about mirror formula. 1 by v plus 1 by u is 1 by f. Radius of curvature is 2f, standard formula. Okay, now before I go ahead, one more thing over here. Remember, the magnification is given by v by u with a negative sign, v by u. This is height wise magnification, height of image upon height of object. Similarly, you have width of image upon width of object, which is the magnification along the principal axis. That is given by minus v square by u square. Keep this in mind. Okay. Yes. Glad to know that, Nishan Patel. Yes. Don't worry, Viraj. We are coming to that. We are going to come to that. Yes. Similarly. Okay. I hope you have noted down these formulas, especially this formula. Very important. Next up, Snell's law. Okay. Sin I by sin R is speed of light in first medium upon speed of light in second medium, which is refractive index of second medium by refractive index of first medium. But while writing, you write it as 1 mu 2. This 1 stands for the medium where it starts the journey. It starts from 1 and goes into 2. So 1 mu 2 is mu 2 by mu 1. That's how it works. Also keep this in mind. This C1 by C2 is also lambda 1 by lambda 2, since frequency is same. Very, very important. The frequency is same for the light. Frequency does not change, wavelength changes, speed of light changes. Keep this in mind. And this can be also written down as 1 upon 2 mu 1. All right, 1 upon 2 mu 1. Keep this in mind. Okay, going ahead. Next, all right, one more important thing. See, if you are an observer, in a rare medium, and let's say there is some object here, that object will be seen somewhere here, and if I call this as the apparent height, this is the original height. Remember, apparent height is original height divided by mu. Very, very important formula, apparent depth formula. Yes, keep this in mind. So yes, very, very important. Keep this in mind. Okay, let's get going to the next one. Okay, now lens maker formula. So for a convex lens, focal length is positive. For a concave lens, focal length is negative. Lens maker formula: mu minus 1, 1 by R1 minus 1 by R2. Everything according to sign convention. Now keep this in mind. If you dip this lens in some weird medium, then understand the focal length will change, because this mu is always the relative refractive index. Okay, but for a mirror, there is no change in focal length. Keep this in mind. Yes, Shreyas, we are coming to that. So keep this in mind. This mu is relative mu. R1 and R2, who are these refractive indexes? Radius of curvature. R1 is the first surface. So this will be R1, and this is the second surface. So this will be R2. In this case, R1 is going to be negative and R2 is going to be positive, because this point is here, this point is here. This is negative side, this is positive side. Keep this in mind. Okay, I hope this is clear. Similarly, if this much is understood, the lens maker formula, once it is done, use that focal length to find the image distance. Here the sign only changes. 1 by v minus 1 by u is 1 by f. That's it. I hope this is clear. 1 by v minus 1 by u is equal to 1 by f. Now, there is again magnification formula, which is image height by object height. That is V by U. There is no minus. Be careful. There is no minus, guys. Keep that in mind. Similarly, magnification this way, which is width of image upon width of object, is not minus V square by U square. It is just V square by U square. No minus. So wherever there is minus, that minus goes away. Yes. Okay, cool. Let's get going to the next one. Power formula. Power is 1 by F. Power is 1 by F. And keep this in mind. If it is converging, it is positive. If it is diverging, it is negative. You can see convex lens will have positive power, diverging lenses will have negative power. Okay, keep this in mind. Now when you have two or more lenses in combination, what gets added? The power gets added. Keep this in mind. P1 plus P2 will be the net power. So hence 1 by F is 1 by F1 plus 1 by F2. Now when is this not valid? Please remember, this is only valid when you have thin lens in contact. So you can replace this with one single lens of this focal length. This is your effective focal length. Alright, effective focal length. Only then. What if they aren't? What if one lens is here, one lens is here? Then use lens formula, make this as the object. Let's say this object is given, find the image. This image will now be the object for the next lens, find where the new image is. That's it. So you have to use lens formula twice. That's how it is. Yes. So if the lenses are not touching each other, use lens formula twice. Keep this in mind, guys. That's how you do combination of lens problems. Sometimes what happens, you might have a lens and a mirror. Okay, lens and a mirror. So what you do in those cases, keep that lens, whatever that mirror is there. If there's a flat mirror, all right, you can replicate that like this. Whatever is there in the front, replicate it behind. Now this looks like this problem. Now it looks like this problem. So now you solve the problem normally, and in the end, because you had flipped it, you had opened it up, put it back in the end. That's it. That's something that you need to keep in mind. I hope this is clear. Everyone understanding this? Yes? All right. Very good. Very good. Okay. Very good. So going ahead with the next one. All right. Prisms. Standard formulas. A is R1 plus R2. Come on. Remember this. A is R1 plus R2. What is R1? R1 is the angle of refraction when the light just enters the prism. What is R2? It is this angle before exiting it out. I1 is the angle of incidence. I2 is the angle of emergence. Keep this in mind. And what is delta? If the ray was going like this, how much angle did the ray deviate by after it emerges out? Delta is I1 plus I2 minus A. Keep this in mind. Very good. Very good. Yes. Yes. Similarly, refractive index is sine A plus delta minimum by 2, sine of A by 2. Very important formula for minimum deviation. Now keep this in mind. The graph of deviation with angle of incidence comes out to be like this. And when I1 is equal to I2, that time it is delta minimum. This delta minimum I have put over here. Alright, this is very important graph. This has come in JEE previous years. Keep this in mind. Hello Santosh, wanna come? Join in. Yes, minimum yeah, now I'm coming to that. Hold on. Yes. So remember this, very important, only for minimum deviation. Okay. But these are general formulas. These are general formulas. This is not for minimum deviation. Keep this in mind. Okay, cool. Next up, dispersion without deviation, deviation without dispersion. Guys, I'll tell you what. If it is dispersion without deviation, forget what is happening. See what is not happening without deviation. Without deviation means that yellow color, or basically mean color, whatever is there, that has no deviation. So the yellow color will deviate in the first prism and again deviate in the second prism. Effectively, there is no deviation on an average, but the light spreads because there is dispersion. but average deviation is not there. So delta of yellow in the first prism is delta of yellow in the second prism. That's it. And what is the delta formula for small or thin prisms? It is angle of prism into mu minus 1, and it is angle of prism into again mu minus 1. That's it. I hope this is clear. Yes. Is that understood? Is that understood? Yeah, everyone. And when there is deviation but without dispersion. Now dispersion formula you should know. Dispersion is nothing but delta omega, and delta omega is delta of red minus delta of violet. That's it. The difference between red and violet's deviation. So if the light is spreading in the first prism, the second prism it collects back. So the delta omega in the first prism, should be delta omega in the second prism. Just do that. That's it. Yes, I hope this is clear. Cool. Write it down. Okay. What is this omega? Omega is angle of dispersion. It's or rather, how much is the dispersion? So usually delta omega is given for dispersion angle. Okay, and it is delta of violet minus delta of red. All right, keep this in mind. Okay, yes. No, Jaswant, I did not have my dinner. I'm going to have the dinner only after I end this session. I'm there for you. Okay, yes. So Shreyas, understand, it is not complete zero deviation. It is dispersion without actually average deviation. That is the correct wording. It's not just without deviation. Other colors will deviate. It's dispersion without the average color being deviated. Yes. I hope that makes sense. Come on, let's do this. No problem, Hatim Ali. I hope you are joined back now. So now it should be clear. My God, somebody wants to just fight with me. Sure, why not? Go ahead. Okay, so radius of concave mirror is 30 centimeter and the size of image is thrice as that of object. Then the object distance is. Come on, guys, do this very quickly. Oh my God, Sarthak, don't worry. There are a lot of lingos that we use. Capto means captain's short form. So that is basically me. All right, that's all. Okay, cool. So radius of concave mirror is this much. Come on, guys, let's do this. The size of image, the image upon object size is 3 times. And what is it, guys? Isn't it V by U? V by U for a mirror. So that's it. V by U with a negative sign is 3. That's all that you need to keep in mind. Now just think of a simple diagram. This is your concave mirror. All right. This is your object. This is your image. Let's just assume that the object distance is x. If the object distance is x, think about it. The image distance is thrice of x. Think about it. So the image that will be formed will be also real, but that should be thrice of x by this relationship. Is that clear, guys? Now use this diagram and solve the problem. 1 by v plus 1 by u is equal to 1 by f. V is minus 3x, u is minus x, focal length, well, radius is given. From this, f is 30 by 2 with a negative sign, which is minus 15 because it is towards the left side. So put minus 15, solve this and see what is the value of x you get. Well, come on, think. What is the answer that you get? What is the answer that you guys are getting? Okay, A? No. I don't think so. Thank you, Tahim. I get that a lot. All right. Well, the correct answer is actually 20 centimeters, guys. Yes. Some of you got it. Very good, Shreyas. Very good. Some of you got it. Well. Yes, just went Viraj. Excelente. Yes. So, Sai Mandeep, if you have been told that re-optics is not necessary for mains, then you have been misguided, my dear friend. It's very important chapter. Every year you will see one question minimum on the re-optics. Glad to know that, Anjdeep. Very good. Yes, let's see next question. No problem, Yalini. Happens. Oh my god. Chalo. Glad to see Priyanka also back. A double convex lens, refractive index, this has a radius of curvature 10. Incident rays will meet at which point? Where will the incident rays meet? Come on, think. Well, Sai Mandeep, in fact, both are very important here. In fact, if somebody would have said leave semiconductors or communication systems, that is understood. But ray optics and wave optics, how can you leave that? That is such an important topic. All right, come on, let's see. Okay. Well, just use lens maker formula, guys. 1 by f is mu, which is 1.4 minus 1 into 1 by. Now see guys, this is a convex lens. Okay, if this is a convex lens, it's going to look like this. Please understand, this will be R1 and this will be R2, and R1 will be positive and R2 will be negative. That's it. Now solve the question. That's it. 1 by, yeah, just use that 1 by R1, which is how many centimeters? 10, minus 1 by minus 10. That's it. So this will become 0.4 multiplied by 2 by 10. Correct. I hope this is clear. So this will cancel. This will become 5. So F will become 5 divided by 0.4. And that should be, yes, 12.5 centimeters. Do not forget to take the reciprocal. That is the answer. Correct. No answer. It's not D. Be careful. It's C. Yes, the answer is C. Yes, Sakti. Correct. Yes, Shreyas. Correct. Pakka. Very good. Correct. Oh. Let's go into the next one. Okay, here it comes. A ray of light normally incident on one of the faces of a prism, refractive index √2, emerges such that it will just graze through the next surface. What is the angle of deviation? Come on, find the angle of deviation. Thank you, Farhan, for all the love. Shilpa, just comment on the video below. I will ping, or I will just post the Telegram link, or second option is just ping me on Instagram. I will share you the Telegram group details. Don't worry, Shilpa. Okay, come on. Let's see how many of you do this. Very interesting question. Let's see. Come on, some of you are saying C. All right, let's see whether it is C actually. So what is given in the question? Think. This is the prism. It is falling normally and it is just grazing. Very important. So this is normal and this is some angle and this is 90 degrees. This is what is happening in that. So here, what and all do we know? Angle of incidence is 90 degrees. Oops, sorry, my bad. Is 0 degree. Because angle of incidence is always measured with normal ray. So angle of incidence is normal, is 0. Similarly, R1 is also going to be 0. Correct? With the normal, it makes 0 degrees. Cool. Similarly, I2, this angle is, that angle is going to be 90 degrees. Be careful. All right. And then this angle over here, this R2, this angle over here, R2 can be found out by critical angle formula. Yes, critical angle formula. So sine of R2 is 1 by mu and that is √2. So R2 is nothing but 45 degrees. Once you get R2 and R1, you can find A. I just told you A is R1 plus R2. So it will be 0 plus 45. So it will be 45 degrees. And delta, I just told you what is the formula for delta, guys. It is nothing but I1 plus I2 minus A. So I1 plus I2, 0 plus 90 minus 45. So that is going to give you 45 degrees. Yes, correct. That is option C. Very good. So Saimandeep, the thing is, in our Telegram group, we have shared all the extracts of all the chapters. Also in the description box of the videos in the playlist, especially the last lecture of every chapter, we have shared PDF of different formulas. So it is there, and also today's session's PDF will come in Telegram group. Okay, Simondeep, let's do this. Okay, but whatever I write on the board will not come in the PDF. Please keep that in mind. Okay, Young's double slit experiment. Come on, guys, let's do this. Yes, let's do this. Let's do this quickly. YDSC, important formulas. Delta x, path difference for any point is d sine theta. Fringe width is lambda d by d. That's all. And resultant intensity is I1 plus I2 plus 2 root I1 I2 cos delta phi. These are the main formulas in YDSC. Yes, these are the main formulas. That's it. That's it. Hello R4s. Okay, let's start doing the problems. Note it down. Alternate bright fringes and dark fringes which are formed. So the path difference at any point is d sine theta. And also do not forget, you can find this delta phi. Find this delta phi by using this formula. Delta x by lambda into 2 pi. This is the formula to get to delta phi from delta x. Keep this in mind. Okay, let's get going. Let's get going. Okay, here comes the first question, 2007 question. Let's see how many of you do this. Amazing, Tushar Saini. Yes, you will do. Why not? Yes. Hello, Ramamurthy. Welcome to this session. Come on. In a Young's double slit experiment, the intensity at a point where the path difference is lambda by 6 is how much? Come on, come on, come on. Let's see how many of you get this. The path difference is given to be lambda by 6. Then, if I0 denotes the maximum intensity, what is the ratio of intensity upon the maximum intensity at that point? Well, most of you are saying B and some of you are also saying C. Well, I'll tell you what. I is I1 plus I2 plus 2 root I1 I2 cos del phi. Correct? Now, because it's a YDSC setup, understand I1 and I2 both are equal. Therefore, intensity, all right, will be I plus I, which is 2I plus I root will be I again cos del phi. Okay, keep this in mind. Now, when path difference is lambda by 6, what will be del phi? Del phi will be lambda by 6 by lambda into 2 pi, which is pi by 3. Okay, so using that, what will I get? Intensity at that point. All right, I'll just call it maybe I1, okay, just to avoid that confusion. Okay, so it will become nothing but 2I1 plus 2I1 cos of pi by 3. What will that be equal to? 2I1 plus cos 60 is half, so it will be just I1. So it will become 3I1. That is I. But be careful, we also need the maximum intensity. Max intensity is when phase difference is 0. Be careful. Yes. So I0 will be 2I1 plus 2I1 cos 0, which is nothing but 4I1. Now, what is the ratio of this upon this? When you divide both of them, what will you get? 3 by 4. That is the answer. Yes. I hope this is clear. I hope this is clear. Understood, guys? So, the catch is maximum intensity is 4 times of I1. Be careful, because when phase difference is 0. Yes, that's the catch. You can see that. Cool. Next question, 2012. Quick question, 20 seconds question. Come on. I'm very good. Reload Tamilian. Come on, come on, come on. Don't worry, Sakti. Happens. Come on, come on. Do this. Guys, I hope the Josh has not died out. Let's do this. Come on. ASN, I would request you to please replay back the previous part and watch it again. And if you still have doubt, ping me on Instagram or leave a comment in the video after the video ends. All right? Cool. So how about this question? Come on. YDSC setup. Which will have most highest fringe width? Beta is lambda d by d. Now whose lambda is highest? Reds is highest, then greens is somewhere in between, and blues is lowest. So the order should be red, green and blue, which is option D. Yes, Sakti is correct. Very good. Oh no, Priyanka, no SL, no problem, no Gansh. Yes, Arya, correct. Well, Feba, just check this out again. Red has highest wavelength. Remember this. Red has highest wavelength. Remember this. Remember this diagram. blue or green has medium, and blue or violet has the shortest wavelength. This is the diagram you should remember. Cool. Let's get going. Okay, now remember there is also a link for joining the test series, and the test series discussion will happen in English, and there will be 20 tests which will be discussed by Shivan sir, Praveen sir and Kundan sir in the test series. You can avail a big discount and you can get the test series for only 1749 rupees. The link is in the description box below, and use the coupon code SHCC for getting that discount. Join the test series if you are a 12th or a dropper student. Last part of today's class, modern physics. Let's do this. Okay, let's do this. Okay, I hope you are ready, geared up. Shall we do this? More 15-20 minutes and that's it. Done. Let's do this. Okay, note this down. Photon travels at speed of light in vacuum. Rest mass of photon is 0. Each photon has fixed energy and fixed momentum. The energy is given by hf or hc by lambda, and the momentum is given by h by lambda or e by c. Note this down. Note this down. Hello Ramamurthy, welcome. Let me know whatever your doubt is. I'll definitely reply. And if E and P are the energy and linear momentum of a photon, then understand that, okay, so if E and P be the energy and the linear momentum of a photon of light, and V and lambda be the frequency and wavelength of the same light when it behaves as a wave, then these are the formulas, basically whatever is written on the top. Remember this, very, very important. And just like photon shows wave behavior or light wave shows photon, which is a particle behavior, even normal masses show wave-like behavior. That wave length is called as the de Broglie wavelength. So the wavelength of a mass like a cricket ball, etc., is given by h by p, where p is the momentum of that particle. H is Planck's constant. Glad to know that, Vignesh Arvind. Thank you so much. I'm really happy. So Ramamurthy, I have already uploaded it. Please check out the playlist of our channel. There is a separate playlist for electrostatics. It's already there. Okay, chalo. Let's go ahead. Photoelectric effect. These two graphs, very important graphs, remember it. Very important. Stopping potential, photocurrent, potential difference. Very important graph. Whenever light falls on a surface, some energy goes in knocking it out, and the remaining energy goes in kinetic energy. So the main equation is photoelectric equation. HF is work function plus the maximum kinetic energy. All right. So this is one equation, and another equation is HF is equal to HF naught plus EVS, because work function depends on the critical frequency. This F naught is critical frequency below which photoelectric effect does not occur, and kinetic energy can be measured using stopping potential. Stopping potential. Keep this in mind. Very, very important formula. Yes, Sarthak Bhatt, yes. If it travels at the speed of light, its mass increases. Very, very important. Remember, these graphs are also important. This diagram should also be there in your mind. Keep this in mind. Shall we go ahead? Okay. Next up, atomic structure, standard. This you have studied in chemistry, so I'll just quickly go through it. These things should be remembered. Radius is proportional to n square by z. Velocity of an electron is proportional to z by n. And energy is proportional to z square by n square. Keep this in mind. And the wavelength of the photon emitted is rz square, 1 by ni square minus 1 by nf square, where r is Rydberg constant, z is atomic number. Saturation current is this current. I'll just come to it just once. Yes, units are also important. Yes. So you should know the shell diagram, transition diagram, Lyman, Balmer, Paschen and bracket series. I've kept it all for you in one slide. Yes, very, very important. Yes, very, very important. All right. So basically, if somebody was asking about saturation current, this is that saturation current. When you apply positive voltage, the current keeps increasing till a certain limit, but there comes a point when whatever photons eject out the electrons, those electrons reach the other side. If all the electrons reach the other side, then increasing the voltage won't do anything more, because no new electrons are being ejected. So that is when the saturation current is achieved. But if you increase the intensity, increase the photons, then the saturation current also increases. That's how it is. Yes. Okay. Next up, X-rays. Please remember Coolidge tube. Properties of X-rays. Properties of X-rays which is given in H.C. Verma. X-rays are short wavelengths of 1 angstrom. They ionize the gas. They are highly energetic. They can pass through flesh. They can cause some diseases in human beings. Also, they can affect photographic plates. But remember, X-rays do not bend when they pass inside glass or water because the refractive index is almost 1. Keep all these things in mind. Okay, I hope this is clear. Next up, when X-rays are produced in Coolidge tube, how they are produced? Electrons are accelerated. They hit the target and those electrons lose energy, and in that process, that energy lost is in the form of photons. Those photons, because they are very energetic, they are of very high frequency and in the range of X-rays. There are 2 types of X-rays. What is this? Continuous. What does this continuous X-ray depend on? It depends on potential difference. Keep this in mind. What does this characteristic depend on? It depends on target material. Yes, it depends on the target material here. This continuous depends on the potential difference. And there is a lambda minimum here. Yes, there is a lambda minimum here. How do you calculate it? E times potential difference is Hc by lambda minimum. Very, very important. Very, very important. Keep this in mind. Yes, keep this in mind. Okay, yes. So that's why Sarthak, because if mass increases when you travel at high speeds, so when you assume the mass itself as 0, then the mass cannot increase because 0 cannot increase. That's the reason of considering rest mass as 0. Alright. So Moseley's law, very important. Root mu or root of frequency is some constant into z minus b. Very important. Moseley's law. Keep this in mind. The graph of root of frequency versus z is constant. Whose frequency is this? The frequency of the X-ray. Is root of frequency of the X-ray is proportional to the target materials. Yes, for characteristic. This is for this, guys. This characteristic, this graph is very useful. Keep this in mind. Okay. All right. Cool. All right. Okay. Yes, let's do the next part, last part, nuclear physics. All the properties of neutrons, protons and nuclear forces should be remembered. Nuclear forces are attractive. They are very short range but very strong forces. They can act between proton, neutron, proton, etc. These forces are charge independent. They are the strongest forces in nature, and the radius of the nucleus is given by a constant into atomic mass number raised to 1/3. Very important. And all atoms, remember, using this you will get this. Density is constant. Keep this in mind. Density is constant. Very, very important. Also remember, one atomic mass unit is 931 mega electron volt, and the energy which is created by destroying a mass, delta m. So that energy is delta m c square. Keep this in mind. So energy created by destroying one atomic mass unit is 931 mega electron volt. Useful for solving problems. All right. Radioactive decay. Come on guys, last 10 minutes. Let's do this. Yes, let's do this. Well, I know Jai Sachin, it is 10 p.m. I know it's almost 10 p.m. Last 10 minutes. Come on, let's do this. I hope you're going to stay, guys. Okay. When a parent decays into 3 kinds of particles, one is alpha, which is doubly ionized helium, or electron, which is beta, or gamma rays, which are nothing but photons or electromagnetic waves. These 3 different decays can happen, and all the properties have been put up in this beautiful slide, which you can download only if you join the Telegram group. So join the Telegram group so that you can download all the properties, or just take a screenshot of all these properties. Okay, very, very important. Alpha rays, beta rays and gamma rays. You should remember this. You should remember this. So that's why I have moved out of the screen so that you can take a screenshot. Okay, going to the next one. Beautiful slide. Chalo, last few questions, 3-4 questions remaining. Ratio of wavelengths of characteristic X-ray K alpha and K beta lines for the same target element are. Come on, come on, come on, come on, come on. Let's see how many of you do this. Come on, guys. Come on, come on, come on, come on, come on. Let's do this. Come on, minions. Do not lose your Enthuse. Come on. Do this. Ratio of wavelengths of characteristic X-ray K alpha and K beta lines of the same target element are in the ratio of, well, think about it, 1 by lambda of K alpha will be some constant 1 by, what is K alpha, guys? What is K alpha? If you remember, this is 1, 2, 3 energy level diagrams. This is for K alpha. This is for K beta. If you remember this diagram, that's it, you're sorted. This will be 1 by 1 square minus 1 by 2 square, which is 1 minus 1 by 4, which is 3 by 4. So 3c by 4. Similarly, 1 by lambda beta will be same constant because target is same. 1 square minus 1 by 3 square, which is 1 minus 1 by 9, 8 by 9. 8 by 9. So just find the ratio. So lambda alpha by lambda beta will be how much? Come on, guys. Lambda alpha by lambda beta will be how much? Do this. Check this out. How much is it coming? How much is it coming? Come on, come on, come on. Is it coming out to be 32 by 27? Very good, very good. Ramurthy, yes, I have uploaded electric charges and field also. There is a separate playlist, electrostatics, magnetism, sorry, electrostatics and gravitation. Check it out. Yes. All right. MHD Faris, don't worry. You can always rewind back the class. Even now also when you're watching, you can rewind back even during a live session and you can catch up. Don't worry. Okay, 32 by 27. Excellent. Next question. The energy of a hydrogen atom in nth orbit is En. Then the energy of nth orbit in singly ionized helium atom. Come on, direct question. Within 10 seconds you can get this. Within 10 seconds you can get this. Come on, do this. Do this quickly. Hello Asmi, welcome. Very good, Arya. Energy of hydrogen atom in nth orbit is En. Then the energy of nth orbit in singly ionized helium atom. Come on. Energy in nth orbit, isn't it constant into Z square by N square? Since N is same, isn't it just directly proportional to Z square? Come on, guys. For hydrogen, what is the value of Z? Isn't it 1? And for helium, what is the value of Z? Isn't it 2? So what it should be? 4 times. Very good. 4 times. Z has doubled. So Z square has become 4 times. So that's the answer. Keep this in mind. Okay, let's get going. Last few questions. Last 2 questions remaining. Very simple. It's hardly going to take a minute or 2. Which of the following is not correct about nuclear forces? Remember this. Which of the following is not true about the nuclear forces? Come on, come on, quickly, 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 quickly. Quickly, come on, come on, come on, come on. You should get this. You should get this. Which of the following is not true? Not true. Not true. Come on, come on, come on. Some of you are saying C, some of you are saying D. Well, they changed to repulsion at a very close distance. Yes. Correct. That is, oh, no. That is wrong. My bad. So sorry. See, guys, this is not going to obey inverse square law or something like that. So understand, the question was which is not correct. I was just thinking about which is correct. My bad. So they changed into repulsion at very close distance. Yes, true, because when they come very close, then they will start repelling each other. They are short range attractive forces. Yes. Understand, neutron, proton, neutron, etc. are very close inside a nucleus. So they are very short range forces. They are independent of the charge. Yes. Because neutron and neutron also can attract, repel each other. That means they are not dependent on the charge. And yes, they change into repulsion at very close distance. When they come very close, then they will not like each other and they will throw away each other. So they obey inverse square law? No. Their laws are completely different. Keep this in mind. Now the next 2 questions are very simple. I'm giving it to you as homework. Find this final element. Alpha, beta, alpha, gamma. Very simple. You can try this out. The answer has been put up in the next slide. I'll just stand in front so that you cannot see the answer. You watch the, you please download the PDF and see what is the answer. And for this question also, I have placed the answer in the PDF, which you can download later on. So try to solve this. All right, try to solve this. And do not forget, the crash course is also available for all of you with unlimited doubts, test series, and also sessions for a discounted rate at 7,000 rupees instead of 10,000 when you use this coupon code. All right, and join our Telegram group. And do not forget to hit the subscribe button and the like button if you enjoyed today's video. Thank you guys very much. Time for me to have dinner, and time for you guys also in case you haven't had dinner. Thank you for all the lovely support that you have given. Please share this video across to as many people as possible. Consider that the least thing you can do to your teacher as a matter of respect. That's all. Thank you guys. Bye bye, and see you tomorrow for the mock test discussion. Take care.